To introduce myself, I'm Jim Bednar. I'm giving this tutorial, but I'm just the figurehead. I'm speaking for a whole team of people. One of those people is Jean-Luc Stevens. He's right over here. He's the author of HoloViews, one of the packages we'll use at some point in the tutorial, and works on lots of the other projects. Delayed coming out of Boston, but probably arriving right about now is Julia Signell. She also works on some of the other projects. And then there are various other team members who aren't here today. There's Philip Rudiger, who's in the UK, who's in Berlin right now. So this is a team effort of several other people as well, but I'll just be going through everything. This is content from lots of people. And as a caveat, this is content that is all brand new, so I apologize. Or great, you get to have the very latest stuff, either one. This is building on material that we've given in, I think, this might be our fourth Scipy tutorial using some of the same tools. But we threw out all the old material and completely revamped it this year. So this is all brand new material, which is going to hopefully work. It's simplified compared to previous years and also has a different balance of what we're focusing on. So I see lots of green post-its. That means people are roughly in order. Hopefully, Jean-Luc will have a chance to visit the people who have red post-its before things get terribly underway. So you should make sure that the first setup notebook here runs all the way to the end and doesn't have any scary messages. So this first line here, we'll check that you have all the right versions. The next one we'll check to make sure you can load bokeh and matplotlib and HoloViews. And the next one we'll check to make sure you have the right data file. If it doesn't say earthquakes here, you've got an old version. This is all new material, all earthquakey based. So it's not anything to do with taxis and so on. That's not in here. All right. So welcome to this tutorial. This is the recently rebranded tutorial named HoloViz. I'll get to that in a second, why HoloViz as opposed to any other name. And the idea is that actually, can everyone read this in the back just to make sure? Okay. The word holo is Greek for whole, entire, and complete. And what we're going to be presenting here is our claim, our point is that this set of tools that we're talking about are designed to make the entire set of things you could do with Viz come together and be easier, more powerful, and have fewer gaps in between them. And so we're arguing that you need visualization from the very first. As soon as you get data in, you want to immediately see, what is it? Is it full of junk? Are there a lot of outliers? Is it a mess? Is it the data I thought it was? And then when you explore it, you want to be able to quickly create a bunch of plots. As soon as you do something, you're going to see something and have a hypothesis. I wonder if that's related to this thing over here. We want to make that easy. And then once you really think you've got something, you need to be able to convince other people. You want to package and polish that and give a nice figure to somebody else. And as soon as you do that, they're going to want to have some power. They want to be able to explore things that you didn't explore, or see what the different ranges of parameters or other ways to look at it might be. And so you want to be able to make an app to give them and be able to have them share some of the power that you had when you were first exploring it. And as soon as you do that, they're going to come back with feedback. And you're going to want to go all the way back to the beginning, to the exploration. Oh, I never thought to look at it that way. Or maybe I should see, is this variable correlated, or whatever. So you need to go back and forth between these steps all the time. And we're trying to make all of them together be practical, powerful, and simple. So why did we need to write anything? Why do we need to do anything at all? Python already has tons of Viz libraries. But that's kind of the problem. We have all those stages, and they're all covered by something in this diagram. Some of the things in the diagram are from our group. Most of them are for other groups. All of them have some reason to exist. There was some need that was unmet until that package was created. And that's how we ended up with this quite confusing situation right now, that a new user comes and sees that. Like, I don't know what to do. I have a problem, and I have a whole lot of tools. Now I have another problem, figuring out which tool to use and whether that's the right tool, how to use that tool, and so on. So why are there so many tools? Because each of the things in this diagram are generally, I mean, there are some exceptions. Most of them are designed to focus on one or two of those stages, and that's the thing they do really, really well. And then the rest of them, that's someone else's problem. For instance, there are ones in that list that give you simple, quick plots, one-liners. Wow, that's a great plot in one line. But then it's a dead end. You can't customize it, you can't expand it, you can't lay it out next to other things, you can't link it up with other things, you can't make it interactive, and so on. Or maybe they have really great capabilities for print-based plots. So the really customized major nature paper, it looks great. But it's not designed to be interactive on a web page so that you could share it with your colleague and they could actually do something with it as opposed to just look at the pretty figure in nature. Or some of the libraries are really great for having interactive Jupyter notebooks. Wow, it's a Jupyter notebook with little widgets and such. But when you try to deploy that outside of Jupyter to the public or to a larger group that doesn't know anything about Python, for instance, and just cares about your science, well, then those fall down because they're limited to Jupyter. And then there are other tools that are great for a small data set. That's most of these, nearly all of these. But if you have a large data set, the first step to using those tools is eliminate your big data and subsample it, or aggregate it, or remove most of the data. And if you do that, then it doesn't work for the step of initial exploration. Because if you've thrown away your data, you don't know what you threw away. If you're trying to understand what the data that you had is, and your tools are making you focus only on a tiny bit of the data, well, that's going to have to depend on assumptions and modeling and understanding of the data. Yes, you can approximate large data set with a tiny subsample, sure, according to some assumptions, according to some model of your data. But if you're trying to use it to really understand your data from day one, as soon as you get it out the box, then a lot of these tools aren't appropriate because they can't handle big data. So it's a bit of a mess, and we have a ton of tools, a lot of capability, and frustrated people. So, what's our sales job? What can we do to help you? I guess I should do an aside. Why do we want to help you? I work at Anaconda Incorporated, so does Jean-Luc, so do several other people involved. Other people involved do not currently work at Anaconda, at least, are separate. But why should Anaconda care? Anaconda actually is a commercial company. I have a boss. We have a CEO. We're trying to go public someday, probably. I don't know. Anyway, it's a commercial entity. So why should they care about open source? They care about making sure that the Python data ecosystem is productive and powerful, because otherwise nobody would care about our commercial product. If the ecosystem is flawed and nobody uses it for Viz and nobody uses it for ML and nobody uses it for anything else important, nobody would buy our product. So we are really trying to study the ecosystem, understand where the weak parts are. Where is it that people are having problems? If you look on the internet, you'll see Viz is a big problem in Python. People are confused by this diagram. They're limited by whatever tool they used. And we don't want that to be. We want everybody to be super productive, super happy, and doing amazing things in Python so that they never have to switch to some other language or some other tool. So that is all that Anaconda is. That's our only interest as a company. And that's the end of anything commercial, I'll say. That's our commercial aspect. Everything else we talk about here, everything is completely open source, generally BSD licensed. So it's all, we earn no money anytime you download anything or use anything. All right, so that was why we're doing what we're doing. So what are we doing? What we're trying to do is to reduce the friction between these various stages and reduce the gaps where you could get something running, but then suddenly, you have to throw it all away and start over again with a new tool if you actually want to go to the next stage. We don't want that to be. We want things to flow smoothly back and forth between initial exploration and final delivery of something. So from the start, that means that we only focus on tools that support web browsers. There are lots of tools. A lot of the ones in here are great tools, but they don't support a web browser. And if they don't support a web browser, you're not going to be able to make an impact with your boss's boss or publish something. And we're from the start, we say we're only going to consider the tools that can have that output, that do have a way forward as a shareable application. Because basically, anything that supports a web browser can make static plots nowadays, but not the other way around. If it's not interactive, it's just not going to be interactive. It doesn't matter. You just get a PNG and you click on it, it won't do anything. The second focus is, obviously, if all you cared about was web browsers, well, then you could use JavaScript. You could use all sorts of cool JavaScript libraries and do whiz-bang stuff. That's great, but that does not help you for initial exploration. Exploring data in JavaScript is miserable. You can make a great-looking app, but you can't make a great-looking app in one line. You can't explore all sorts of possibilities in JavaScript in one line very easily at all. I'm sure some JavaScript person will see this and come back to me, but anyway, that's my position. We're not worried about people who are great web tech developers. If you are, go. Enjoy. But here it's, what can you do in Python? If Python's your native language and you can explore in Python, how far can you get in just Python? The third bit is that we want to make sure that there are no data restrictions wherever possible, so that you just work with your data. You don't have some model or assumption about it. Can we eliminate those? And in many cases, we have. So we don't want to have the data set come in and force you to switch to a new tool. You should just easily say, oh, okay, I'll do a little different, but I'm still with the same set of tools. So that you don't have to worry about the data size. Lastly, we're only focusing on ways that you can be in a Jupyter notebook and it's interactive and it's great. And you can also be in a batch job and it's rendered to a disk, and that's great. Or you can be in a deployment situation where there's no Jupyter, there's no live kernel with executable code that the user can modify, but it's deployable, it's shareable, and that works great too. There should be no reason that things can't work in all these scenarios. And then the last bit is a little more of a philosophical one. That we focus on providing high-level, quick, convenient, one-liner kind of tools that are shortcuts rather than dead ends. And I'm going to keep using these terms, so I actually drew a diagram for it. Why do I say shortcut, not a dead end? In the middle, this is illustrating a shortcut. If you have a high-level package that gives you 3 choices, and let's say you wanted to be over here, you wanted to have this particular thing, and you were able to choose between options 1 to 3, and you chose option 1, you got pretty close. That's great, right? You got real close. You made one decision. I picked from a menu, like being in a restaurant. You're not a chef. You just pick from a menu. Anyone can pick from a menu, right? Doesn't take expertise. You just pick one, you're done. That's great. And if that's all you need, and you never need anything else, you are done and never need to revisit the decision. But what if this isn't close enough? What if you really did need to be here because your boss says so, or for whatever reason? If you needed to have it precisely the thing you wanted. Well, you could switch to an entirely different set of tools where you're making decisions all along the way, requiring lots of expertise, and eventually you can get there. You have to learn how to get there. You have to even know that the tool will get you there to understand. You have to have the expertise to choose the tool, make all these arbitrary decisions, seemingly arbitrary all along the way, and eventually you can get there. This option represents power, but it requires expertise and time and commitment compared to the high level. So instead, we're going to focus on tools in the third category here, layered tools that start out at a high level, get you close, and then you can drop down if you feel like it. If you want to study this little general region here and map it out and understand that you can go from here and around and over to here, you can get exactly where you need to go. And so all the tools are designed this way. We start out, we give you a one-liner, and then we say, hey, what if you need to be more specific? What if you didn't want that to be red? What if you wanted it to be purple? Then this is what you do. This is how you drop down to the next level. So basic idea of shortcuts, not dead ends. I don't ever feel comfortable using a tool that's a dead end, but I'm super happy using tools that give me quick shortcuts as long as they are not a dead end. Okay, so that's at a very high level, but it motivates all the things that we're going to do in the tutorial. So we'll try to start out with an easy one-liner, and then we'll say, okay, having done that, what can you do? Explore the neighborhood around it, and then when you really need to do something more detailed, here's how to go to the next level, and then repeat as necessary. You can go to the next level, and then the next level, and the next level, and eventually you're bottoming out like anything in a web browser at HTML, CSS, or JavaScript. That's where it all bottoms out, and you can go all the way down there if you need to, but hopefully in your daily life you won't need to very often. And hopefully when you do, you'll be able to capture that and then just reapply it later instead of spending your life working at HTML, CSS, and JavaScript. So that's our sales pitch. That's what we're trying to get you to be able to do. And so to make that work, here's what we did. We started out with that landscape and we selected. We selected number one, we didn't select any tool that was dead. And there are about 5 on here that are just dormant projects. No one's maintaining them, so those aren't really relevant. And then there are other projects that are completely irrelevant, such as the OpenGL-based packages. Those are great packages, but OpenGL is not a web standard, it's a desktop standard. And so we'll only really consider things that work at the web because of this entire life cycle. So if you need to be on the desktop, if you really want to be in an immersive cave with viz all around you, this is not the tutorial for you. Someday maybe it could be, but that's not where we've been focusing. So we don't focus on any of those libraries. And then we also aren't focusing on strict JavaScript libraries. Like, those are great for whoever wants to mess with them. We're not going to tell you how to use a JavaScript library directly. And then there's one more category over here of widgets-based libraries. There's only a technical reason why those are not included, and we are working on that. Basically, there are various interfaces defined by widgets that people have shown now. All the things you hear in this talk today can be used with widgets, but not currently vice versa. But we have ways around it. We're working on it. We're discussing with widgets people. We think that we can make that happen this summer. I don't want to pin down anymore. So that will light up all of these libraries over here as being usable with everything else we tell you. And then there's a smaller subset, which is the stuff that we use in our daily work all the time, and it works super well. And for most of our work, this is all you need. So you can use anything on here, no problem at all. We typically use just this subset. So we use either bokeh or matplotlib for the actual plot rendering. We use Card2Py for geographic work based on GeoViews. We use Network for graphs and networks, and so on. We'll get into some of those details. But we have the best and most support for these things. And then that brings us to the actual libraries that we maintain. This is a subset of them, unfortunately. We maintain a lot of libraries. Basically, my situation is we have a lot of government and academic and corporate clients, and we work with them and try to solve their problems using open source. And when open source doesn't solve their problem, we end up with a new library. So gradually, we get more libraries over time. For instance, Datashader came about when we needed to deal with larger data sets and nothing else was going to work. Color set came about when we were frustrated by the difficulty in creating perceptually accurate color maps under certain circumstances. So we just wanted to capture a bunch of those and publish them so they're easily available. GeoViews came from some of the pain of trying to work with geographic data that you need to reproject. And then you'll learn a lot about these first two. So basically what these libraries do, panel is something that we're going to argue that everybody should use all the time. Basically, panel, it doesn't matter what viz library you use or what you're doing, you can use it to put things together and make an app immediately or a very complicated dashboard to share. It's a very general package and doesn't assume you're using anything else in the list. hvPlot is a super easy way to get interactive plots, such as from Pandas. If you've used pandas.plot, you can use pandas.hvPlot, and you'll get an interactive plot instead of a static PNG. And then we'll deal with the rest of them as we go through. And just to acknowledge, all we're doing is putting a little layer on top. All of the real heavy lifting was done by all these other libraries. And in most cases, we haven't needed to mess with those libraries. We do a little bit of work on bokeh, we've done a little bit of work on matplotlib, a little bit on pandas. I guess we've done a little bit of work on all of these, it turns out, if I look at that list. We didn't mean to. We only when we found an actual problem. Those weren't where we were spending our time. We're spending our time at the high level, thinking about the user and the user's problems, and how can they assemble these low-level things that are already out there in the Scipy ecosystem, how can they assemble those to solve their problems? And that's where our tools fit, between the number crunching, the hardcore stuff, and the user's problems. There's an intermediate section that we focus on that is about general problems that cut across domain and discipline, but are about what the user wants to do with data. That's where nearly all of our pull requests go to those libraries, not to the underlying ones. And so we don't actually work on plotting very much. Plotting is done by bokeh and matplotlib. We work on assembling everything that can eventually become a plot, or organizing and laying things out. But you'll see that. All right, so what are we doing here today? We're going to learn how to create apps and dashboards. If you've got a Jupyter notebook, you should walk out of here today with, okay, I can turn it into an app, I can turn it into a dashboard, a few lines of code, and I can share it. It's interactive and I can share it. If you don't walk out with that, we did something wrong. You should easily be able to get interactive plots out of Pandas data frames or Xarray arrays. You should be able to easily work with columnar data, like in Pandas, big data sets, which means anything that would cause your laptop to have trouble, geographic data, or multidimensional array data. We should be able to, although this is starting to get more tricky, so not everyone's going to achieve this probably today, to be able to set up heavily interlinked views of a data set where you're looking at this dimension, and over here you're looking at a different slice of it, a different subset, and everything is all linked up together and interrelated. We're going to talk about that, but that's in the later part of the tutorial, where some people's brains will be tired by then. So we can't promise that you're going to walk out with this, but it is in there. And throughout, we're going to talk about the whole process from getting the data in, cleaning it, figuring out, validating it, exploring it, trying to communicate something you've learned about it in your exploration, building a dashboard so someone else could learn something, and deploying those. And in terms of organization, what we do is first, at the beginning of the tutorial, like I just mentioned, you start out with the things that really should apply to everybody. And then eventually at the end, you're becoming more and more expert, and you've also committed to using a particular tool. At the beginning, you can use these tools with just about anything. And at the end, we can't cover all the possible ways you can do with every tool. So we've chosen specific tools and say, this is how you do it with this tool. When you really need to dive in and connect this little bit to this little bit to this little bit and make this happen when you do that, that starts to get very specific. So it'll become more and more specific over time. So I'll show a little bit of demos, then take a breath, and then we'll jump in. Before I do the demo, I see one red post-it, and it's being addressed, I hoped. Okay, all right, we're a good step. I talked long enough to distract everybody so that you can get ready. There's always has to be that buffer while people get their environments set up. So any immediate questions, burning things that you feel I should not go on with, go on until it's addressed? Okay, then I'll give you some demos, and the point of these demos is not to make you go ooh and ah unless you want to. It's to give you an idea of where you're headed. This is what the sort of things you can do with these tools. It's what these tools are designed to do. So just to start out with, I missed it somewhere. I was going to explain the difference between PyViz and HoloViz. PyViz is an organization we set up a year ago, maybe, I guess a year and a half maybe. The idea at the time was to kind of unify the world of Python data visualization. And since then, we've been struggling with it a little bit to understand how to negotiate with all of the different players. Because as you saw in that diagram, there are a lot of libraries and a lot of people at different goals. And what we've worked out is that we should make a very clean break between what our group says to do, which is don't worry about desktops, don't worry about 3D, worry about web applications, because eventually you need to share it. That's what we say, and other people have different opinions. We've separated it out now because it was causing lots of confusion. PyViz is completely general. PyViz supports Viz and Python. That's it. Every possible Viz library, if you click on the All Tools section of PyViz, you'll get a list of all the tools that appear to be viable in Python, and all sorts of stats about them. It takes a while to load them because it's actually contacting a whole bunch of different services to find out, oh, that's cute. Missing number is missing its license. It's missing more than numbers. I didn't notice that before. Anyway, these are all live status updates. So it's showing you that, for instance, matplotlib is being downloaded on PyPy 7 million times a month. That is a lot of downloads. 100,000 a month on Conda, and so on. And so they're sorted in order of popularity. These are the core libraries. We're going to tell you how to use this shared API. There are native GUI tools. We're not going to focus on that. 3D-based tools, we're not going to focus on that, and so on. So there are lots of tools there. You can see which ones are up to date. You can see which ones, this is a useful one, which ones are dormant. Nobody's updated in 2 years, or the author said, I don't use this, you shouldn't either. And some of those that are in this list, the biggest one is what, 79,000 a month. Okay. So people are using this library. Nobody's been updating it in ages. It's got one contributor, and he says don't use it. But 79,000 people, that can't be right, can it? Well, anyway, I wouldn't pick one from this category if I were you. I would pick another. So basically, PyViz has various talks about comparing libraries. I wrote the first one. The rest of them are all other people. And the first one is basically kind of the content of this website, how the different libraries compare to each other. So that's PyViz. Even you can walk away with that. So starting from the most general to the most specific, most general, PyViz, anything to do with Python data visualization. We won't talk about that anymore. We'll focus on HoloViz, which is specifically what my group says to do. These are all a bunch of people who I work with. We all agree this is the way to do things. You don't have to agree, but we're presenting a coherent case. This is what we do, and this is how to do it. So this is the HoloViz tutorial, previously called the PyViz tutorial in other years. Okay, and then if you drill down further, you can go to an individual website. There are links to all the websites, but for instance, to get to panel and so on. PyViz also hosts a bunch of examples. These are good starting points. Most of the things I'll show you in a second are from here. These are self-contained examples that are fully reproducible and are also deployed. So if I click on this one, that's the glaciers one. Here's the glaciers example. If you click on that, you'll see all the code involved, and then you can see it deployed as a dashboard. So basically, this is a useful overview. This is also at pyviz.org. This is a whole bunch of example projects. Can be from any tool. Most of them are illustrating HoloViz tools, so it's a good place to launch things off. So I'll just launch into some of those, just as an example. Here's an example of something you can do with HoloViz tools, which is, if this particular one is exploring glacier data. There are 213,000 cataloged glaciers in the world, and these are their locations. These are the latitude and elevation locations of them. If I want to only look at the ones in around Nepal, I can select that if I wish and focus in on that. It's being very slow. Maybe everyone else is downloading stuff for their tutorial at the time. But you can cross-link between each of these. If the internet weren't bogged down at the moment, it would be contacting that server, telling it to update, and it would display here. Most of the ones that we use in the tutorial will be running locally here, so they won't be subject to internet. This particular one is deployed for the public. So that's one example. It's quite like what you'll build up to in this tutorial today. These are glaciers. You'll be plotting earthquakes. This is another example. This particular one is just, it's widget heavy. Again, being very slow. But if it were, well, I'll focus on one that's actually running here. I'll just run this whole thing. So this particular one, there. I'll just run it locally since the internet connected ones are bogging down a bit. So here is a local version of this. This is just plotting physics attractors. And this particular one is about 4 or 5 lines of code. And all it does is take a function of these parameters, use it to calculate trajectory of a point in a plane, and then iteratively go around the points in the plane. And as you change the parameters, the shape of that changes. And so making this particular one, the code for that is here. I have it in various versions, but the final code that's being used is, this is just saying that there's an image, there's instructions, you lay it out in rows and columns, and what it's laying out was declared Up here was, so it's basically every time I drag one of those sliders, it's running this function. So that's the extent of it. That's what it takes to make a plot like that, wherever it was. Okay. And this is just illustrating that these tools, Panel will work with any plotting library just about. This is the same plot from Bokeh, Altair, Plotly, or Matplotlib. And they're all controlled by this interactive control. That's probably not going to work either if the internet is, yeah. So luckily I don't need internet after this. All right, this is an example of working with big data, which is, this particular one is plotting GPS coordinates, plotting 1 billion of them from the OpenStreetMap project. That's approximately what my laptop can handle. This is running locally on my laptop. And if you, just to give you an idea what it means to handle big data in that case, if I were to put 1 billion points into my web browser, I said we're focusing on web browsers, right? But if I were to put 1 billion points on my web browser, it would die at about 300,000. They're just going to crash. It's just like, oh, this web page is going crazy. You're going to clamp down and not going to allow that. And even before that, it becomes quite slow. But in this case, what happens if I zoom in here is that all of the data is being held in Python. When I zoom in JavaScript in the web browser, it's contacting Python and saying, hey, can you give me a new image for my new zoom level? And so briefly you saw it wasn't updated, and then it went to Python and it came back. And so in this way we can make it easy to explore very large data set sizes up to what your memory can hold or up to what any distributed cluster can hold. So, and the code to do that is about 7 characters different depending on whether it's big data or small data. If it's big data, you wrap it in this extra thing that says, pre-render it at server side before you put it in my browser. And that's it. So it makes it much simpler to explore things that you, this actually is 0 parameters. There was no tweaking or, this is just the default output of the program. It just does that when you give it data. It'll just show it. And in fact, it'll show, if you zoom out, you can see it shows all sorts of artifacts here. This is just the raw, unclean data. It just shows those artifacts are something to do with satellite tracks is my theory, but I don't know. One more thing you can do with the tools, you can actually, because they're fully interactive, you can do things like add data points. You can drag data points around if you want. And in this case, it's adding data points and here, so if I, here we have a plot, we've added some data to it. You can actually pull that data back out into Python. So you can use this to collect data from a machine. If you could use it to tag data from machine learning, for instance. You can use it to collect annotations. You can use it for all sorts of nefarious purposes. And once you've added something, you can edit various features of it, so to label it. So we won't get into any of that in this tutorial. That's kind of advanced usage. But just so you know that it's available, it's fully interactive, and you can do all sorts of crazy things with it. You can use it as a drawing program. You can use it to collect user data, to record your own feelings about the data, whatever. So that's advanced usage. It's not that hard, but it is more than we can get to today. Then this is there's an example of a larger kind of dashboard. This particular one is, I think it's actually running here. Yeah, this particular one is similar to what you just saw, but adds a bunch of things you can customize about it. Each one of these each one of these widgets on the left is tied to some aspect of what you're seeing here, either controlling the labels immediately or controlling the whether you can see the data. And it's tied in a way that each little bit is immediately active and controls only the computation you need to. So if you needed to change something that did determine, like here it's changing what you're actually plotting. Now that takes a second to update because it actually has to regenerate all of the data. So you saw that took a second. It actually had to touch memory for that. The rest of these things happen in my browser and it's all fine. And the code for that is roughly 50 lines. I think it is this. Essentially, you define a bunch of, you define a bunch of possible things you might want to change. You define a bunch of parameters for the things you want to change, and then you tie each little bit of computation to one of those parameters. So that's what you'll eventually get to. And I think that's it for the yeah. Okay, so that was just demo. Yes, come on in. All right, so we're ready to actually get started running the tutorials. I suppose I should take one break to rest my voice. Is anyone else having any problem with running tutorial 00? Okay, so the one person who's got Jean-Luc extension. Okay, so we're going to start now. We just did overview. We're going to start with number 2. By the way, there's a schedule. The times in that, since we've never given this material before, are entirely made up. They do add up to 4 hours. And what we give will add up to 4 hours. So there'll be some relationship there. It'd be great if somebody could, in fact, I'm going to take note of how long things took. So that was 110. Okay. So everyone should have tutorial 2 open. If you have the index set up, that's a good way to launch all of the various ones in the right order. Because we did set up, we've done overview, we're doing building panels now. Which I know I've got 2 copies of, so I should get rid of one. Okay, these notebooks in general are designed for either run all or cell by cell, but most people probably will run them cell by cell. So that's what I'll do here. Hopefully, if you execute this first line, it will not fail because you ran the setup. It didn't fail for me anyway. This is showing you the one-liner. This is how you get a. So we're going to start off immediately with panel, and the reason for that was that it's general. No matter what you do, no matter what plotting library you can always use panel. And so this is illustrating that here. It's not even with plotting, and in fact, in this notebook, it won't be with plotting. It's just being able to run a particular example, a particular function here, and display what it generates. So if anybody has problems now, they've done this, put up your the red. Okay. And so what we got here was we actually immediately got a widget, and what this widget does is select a row from this data frame. What is this data frame? It's actually the data frame is a subset of data frame ahead. It's a bunch of locations of earthquakes and their magnitudes. So it's a couple of million of them. If you try to run it on your laptop and you have problems, there is Jean-Luc can come help. There's a smaller version of the data that's also installed. But hopefully 2 million is not too much for people. Okay, so let's say you've used it, and so immediately you can get a little widget and controlling a display. So what's happening here? All that's happened here is that we wrote a little function that says select row, and it returns the data from that row in that data frame. That make sense? All right. So if you have that function, you can pass any function like that to interact. You pass the function name. It will inspect the function's signature and know that it takes an argument. In this case, I had to specify that the row goes from 0 to the length of the data frame. If I didn't specify that, often it can figure out a good range, but it's always helpful to tell it the exact range you want this widget to go from 0 to, in this case, 2.1 million. And then when I drag this widget, or if it had multiple arguments, you'd get multiple widgets. If I drag it, every time I drag it somewhere, it's going to call this function and display the result. That make sense? So this is a trivially immediate way to get something working in a web browser. And at this point, we haven't chosen any plotting library. It'll be a while before we do. But this is, so this is our first illustration of shortcuts, not dead ends. So that's a shortcut, right? Great. Super easy to get a web app running. But what did we get from here? Can we do anything with it? You can actually print that thing that you got. So if you've called this interact function, you'll get an app. And then if you print it, you'll see that this is actually a column containing a column with a widget in it and a row with a bit of HTML in it. And the HTML is actually the representation for this data frame. The widget is this slider here. So what the interact call did was to create this compositional object and return it and display it and make it work. So why is that not a dead end? Well, it's a dead end. It's not a dead end because you can actually do whatever you want with it now. You can index into it and take the first item, which is this widget. You can take the second one, which is this display here, and you can add some text to it in Markdown, and you can lay all that out in a column and a row rather than in whatever the default was. And now it all still works the same, but you've been able to reconfigure it to do whatever you want. Like you can, and you'll see later, you can add images, you can add plots, you can add whatever you like. Everything has already been instantiated, connected up, and is ready to go, and then you customize it. So that, in that way, it's not a dead end. It's a shortcut. It got something quickly, and then you can expand on it. And then there's another way it's not a dead end, which is if you really need to customize everything, we show how to do that, how you can get the same result here by laboriously doing every little bit. And that way you don't have to switch to some other tool. You do have to drop down a level in API. All right, so those are widgets and apps and so on. Those are just examples. Now let's dive in and actually do something. What are the things that we're going to do? So what are we illustrating here? There are three types of thing. There's a pane. This is a pane. No pun intended. This particular one is a pane. This particular one is also a pane. And in that pane is a widget. Well, actually, that's a panel. If you look at this, there are things called panels, widgets, and panes. Panels are containers. So this is a column panel with a column panel in it and a row panel. Those are all panels. So a panel is something where multiple things potentially have been laid out together. A pane is one of those things, and some of those things are widgets. So this is a widget, this is the pane, and this is a pane here, and together that is a panel. Make sense? Those are the three things that there are. And there are lots of choices for widgets. There are lots of choices for panes. There are only right now 3, and then maybe there will be 4 panels. There's a row, there's a column, there's a tabs, and there's a grid spec that lays it out in grid. So I guess there'll be probably 5. Okay, we already showed Markdown. In this case, if you want to get a pane, confusingly you call the panel function to get a pane. Whatever. If you call that function, you'll get a pane in this case, and it'll display itself. The key thing of panel is that everything you combine with everything displays itself and is live and is connected up. It's not just a picture of something. So in this case, what is this title thing? It turns out it deduced that it's Markdown. And that's just there's a set of priorities. It tries to see of all the panes, which one does it match and which one's the highest priority. Oh, hello, Julia. Welcome. I didn't see you come in. So that's Julia Signal. I suggested she might arrive at some point, and she has. Welcome. All right, so this particular one is Markdown. If I'd put something else in there, it would have had a different type. For instance, here is a PNG pane. To get a PNG pane, just pass the path or a URL for PNG, JPEG, GIF, any of the common things like that. You can, in a common image format, SVG, and it'll display that. And this is another example of an HTML pane. Okay, so time for your first actual exercise. You get to type now, this far into it. So try to display something. Like, I will give you the first one, which would be, that's easy. What else could you do? Well, let's see. Does internet work yet? We'll be having earthquake-related things. Let's see if we can get a picture of an earthquake. Oops. I don't know if that's going to be a picture, but I'll see. Okay, I'll try copying the link and then put it in here. But it only works if it's a real link. You'll see in a second whether if it's a base 64 encoded thing. Well, that one's not bad. Okay, so maybe this will work. It does work. It's very big though. So let's make it small. Okay, we got something. You can do that with any reasonable data type you can think of. Strings, HTML objects, things that display, anything that will display with IPython's display function. There's a big list of them at the panel website. I think it's listed here. This is a little bit out of date, but it's a long list of things you can display. Bokeh plots, Plotly plots, Altair, Vega, BTK, HoloViews, hvPlot, Matplotlib, ggplot2, YT, anything that has SVG, anything that has PNG, anything that has JPEG, HTML, Markdown, equations, various widgets. You can even have editable code. I haven't tried that one out. So, all right. So, how many people, raise your hands if you've gotten something to display of any sort, like text, I hope. So, anything like that will be. And if you did something that it didn't know what to do with, like, let's see, int, that's a type. It will display that as a string. So everything sort of bottoms out to have a string representation. So even if it can't handle it, it can handle it. It's just not going to be necessarily that useful to show the int type.
It did fail on one thing.
What did it fail on?
The top level data frame.
The what?
The top level RTX task data frame.
All right, let's try that. So what is that? All right, so that means that it has a repr to HTML. It has an HTML representation, but it's not succeeding at getting HTML out of it. So it's trying that. And so if you have that problem, then you could do it's an explicit. If you have something and it's not working by default, you can do. This is actually shown down. You can explicitly force it to be some representation that will work. For instance, string will always work. Surely that will always work. And so it's trying to get by default, it tries to get the richest representation possible. If there is some problem, in this case, I don't know what it takes to display a Dask as HTML in here. But if there is some problem, you can specify a particular thing that will work. Okay? So that's fun to see. We should investigate why that is, since it's in our own tutorial. And it's something people will readily try. I should undo that. I just did the second thing. So the next thing said, make it explicitly build something. So you can explicitly build it by specifying the particular type of pane. And if you want to find out what those are, just use tab completion. So you can find out all the panes that are available. And many of them handle lots of different types of data. So, all right. Okay, so so people in general are able to do those crucial first exercises. Okay, so that's now that you can. That means you've got something and you've gotten it to display. Now you need to be able to lay it out, and that means to arrange it somehow in a row or column or a grid. We won't cover grid. But in this case, we can make things be a column, or we can make it be a row, or we could make it be tabs. And probably tabs shows one or the other, but not both. Probably want column in this case. And you can nest them arbitrarily to make anything. And the things that are in it can be responsive, so that I don't think we have examples enough of that. We need to put more, but they can be responsive so it covers the whole screen. It'll automatically resize and such. Let's get a little bit more ambitious and try to do something that's more dashboard looking. In this case, it's doing a 5-row data frame next to a title above a logo. We have, by the way, we have no association with USGS. Perhaps that we want to make that clear, because that logo is that this data came from USGS. USGS did not do anything to do with any of our examples. But the data is probably worth far more than anything we will do. So strictly speaking, they should own the whole thing. All right, so this is one example. The exercise for you is to take several of the things you did before and lay them out together. So pn dot, so what's a good example? What should I do now? How do I lay things out? You need a container. It's either going to be a row or a column. So like a row. And then I need something in it. So how about df2? Yours might just say df. I don't remember whether I pushed that change. I changed df so that the first thing and the last thing weren't both called df, so if you execute them out of order, you won't have any problem. Okay, so this is a row with one thing in it. Now we can also add something else. But that's too small, so let's make it big. And it doesn't mean anything, so. Okay. Oh, and there we go. It's already telling us to do tabs. So now tabs are for when you want to choose between the two things. You don't want to lay them out together, but you want them both to be available. Okay. Note that these things are all reactive, which is the next point. In this case, what if we were to change the objects? There's an object right here. It's displaying it, and you're displaying something. What if we were to change the contents of that object? You notice that it changed in the preceding cell? That's because this title, it looks like it's just printing a little bit of markdown. It's actually got a lot of power behind it. And if you do title dot, there's a lot of stuff in there. Title is not a trivial object. Title does lots of things. And one of the things that it does is that it can watch. And in this case, it knows that when its object parameter changes, it needs to be updated. This is an object, and it has a parameter confusingly called object. So the underlying object for this title object, if I query it and ask for it, I can find that what is the data inside that title? It's this. And if I change it, then it will update. Okay, that makes sense? So this is how everything is going to work. Whenever you need to link anything up, it's because one thing changes and something else responds to it. And the same is true for the for layouts as well. So if we update the underlying thing, the thing that's containing it inside, no matter how arbitrarily nested, it will also update. So we can have dynamic behavior where we're updating everything all over the place. And it all should just work. You don't have to just update it, you can even append to it. In this case, you probably missed it, but if I told it to append this text, it's now got 3 things in here. It used to have only 2. If I do it again, it'll get 2 copies of it. Make sense? These are basically lists. So a row or a column or tabs is a list, and you can insert in the list. You can reset the list to whatever you want. So you can set the here it's using a pin, but you can pop off, or whatever you can do with a list, you can do with these things. So you can manipulate it. Just imagine it's a list this way or this way. Oops. Normally we have a little spot for you to have your to do your exercise, but basically. The exercise is to create a new panel and then replace the component. It's essentially the same thing I just did though. And then the last thing that gives you the power is if you just type row, you'll get this thing. Let's get rid of that. Where's row? There. Okay, so if you just type row, you'll get this thing, and you can see it in the notebook, and that's all fine. What if you did want to share it, though? So somebody who doesn't speak Python. Well, you can immediately do this, which will launch a separate server with the thing you just made. It's running on the same laptop, so it's not fully public, but it shows you it's something that could be fully public in a second. But it's running here, and if somebody were to hack into my laptop and go to, I can't even read it, whatever that port number is, 64 or 831, if they were to go there, they would see this running dashboard. So usually the .show command is just for debugging. In reality, what you would do is you'd hit save here. I didn't have this set up, but let's see. I'm just going to type the name of that notebook. There may be already one running. I should say show. So if I type panel serve-show and then the name of this notebook, this is a completely standalone copy. It's taking the code in the notebook. It's going to execute each of the things in the notebook cell by cell, and then eventually, having executed all of that Python code, if it works, since it's totally untested, seems like it should be. It should launch the exact same thing as when I type .show here. So either way, you get something running at localhost and shareable. And this is key. The fact that it works at a command line that has nothing to do with Jupyter means that you easily go work in Jupyter all you want and then can share it with people. Just all you need is the ability to run that command. So if you get some cloud resource and you run that command in the cloud on that server and you point someone to the URL, you're done. That is your deployed dashboard. You wrote it in a notebook, you saved it as a notebook, but you were able to publish it. And then anyone who gets to it has no access to the code. They don't see the code. They don't know what the code is. Hopefully you've laid things out when you put the right explanations and the right sources, and this is all they need. So you've packaged up what some external consumer of your analysis needs. Make sense? Okay, I think, well, you can certainly do that exercise. It's very quick, though. I think we're ready for a break on the schedule. Yes. So that's arguable. That's exercise 1 is basically the same exercise at the end of that tutorial. I'm going to take a break for a minute. You play around with it, do something, and then do .show to show it. Okay, somebody had a question about .servable because I completely failed to explain that. And the answer is, if you have something marked .servable in your document, there must be something in here. Oh, there it is. There's something marked .servable. You can have multiple things, but if anything is marked .servable, when you go to the command line and you run it, the dashboard that you get is going to be that thing. So what happens is .servable has no effect on the notebook where you wrote it. It's just swallowed, ignored, but it's there. And then what panel serve does at the command line, if you do panel serve in the name of this notebook, which is what I did here, then what it does is it iterates through, it executes every cell in the notebook, and anything that's marked servable is registered with this server as something to display. And so when I did panel serve in the name of this notebook, why did I get this particular dashboard? It's because that particular object called row was marked .servable. If I mark something else .servable, I will get a different dashboard. So if I take that off and I mark pretty much anything. If I save that and then I run the same command, now I'll get a different thing as my servable dashboard. Let me make this bigger so you can read it. Maybe that's too big. Okay. So when I run this command, it should now serve the different, very boring thing that I just marked as servable. And if I mark, hi Tim. If I marked multiple things servable, then it actually just stitches it all together. So now it should, this is, marking multiple things servable is usually not that useful, but in this case, this is what happens. You get all of the things you marked servable. Okay? And this command here that I ran has nothing to do with Jupyter. I could have taken that same code, put it into a Python file, and put that here instead. It handles Jupyter notebooks, but it doesn't care whether it's Jupyter. It just cares that it's Python code, and somewhere in it, somebody's registered something as being servable. And that means that you've got your notebook, you're able to serve it here, anywhere in any system that you can run this command. So you need the environment that we had, you need the things installed, but if you can run this command, then you can launch the web server, and at that point it's up to you to figure out the firewall, permissions, authentication, things like that. It handles none of that for you. It just starts up a web server, it's listening at this port, whatever port it says, 5006 in this case. You can control that port number, and then you can share it. So, yes?
So when I run a panel, this starts a bouquet server, and people can connect to it on the port. If that thing's being served has widgets in it, then everybody who connects to that port is going to see the same activity on the widgets, or they won't have their own?
They have their own.
So they have their own...
That'd be fun to do, to try to get everybody to contact my laptop, but I'd have to change the...
so everybody gets their own kernel?
No, they don't get their own kernel. They all share the same Python process, but the way Bokeh Server works is whatever the thing that you're sharing, it's got its own local state, and that is what you see. So when you see it, you'll get your own widgets. Other people will see it, get their own widgets.
So it's got some concept of session management.
It's just running JavaScript through the browser.
So you don't replicate any of the big data for each of those sessions?
The big data stays behind in Python. Bokeh has client JavaScript code that's running on everybody's web browser. Everybody who contacts it runs different client code, and therefore they've got different widgets on their browsers. The widgets are local. At the other end, it'll be contacting Python. Python has a copy of the big data. The big data never went to your web browser. It stayed there. And the pro of that is that it never got downloaded, didn't crash everything. The con is that if you are tied to Python, you need this running server. You can't just have a static HTML. And so we won't really get to it. We'll touch on it in a few cases, but you can export things to static HTML, so it's all running in your web browser. There is no server behind it. There's a limited subset of things that you can do there before you have to start writing little bits of JavaScript. Because basically everything that we've prepackaged and arranged and set up as a nice affordance, great, you can do that without needing Python. If you need to have custom things written in Python, well, that Python has to exist for you to run that when you touch a widget. Okay, that was tutorial 2. Having had that, you should be able to walk out of here and set up some some panel for anything. We don't cover any plots. You should be able to go to the website and figure out how to use the various different types of plot. Unfortunately, the most popular plot, matplotlib, is also the most difficult because it does all sorts of it's got weird interactions with the notebook that make it want to do side effects rather than return objects. Panel is assuming that anything you want to display is returned as an object and it is displayed. Like the same way a number works or a string or everything, it assumes things work normally. That's not true. You have to really work hard on matplotlib to make it work normally, like a normal Python object. But the panel website explains how to do that. So if you want to set it up, if you try matplotlib in the examples, the quick answer is if you're a matplotlib expert, pay attention. Otherwise, ignore this. Basically, close your figure before you return it, and then it'll almost always work. close the figure doesn't destroy the figure. It basically it's matplotlib inline tries to display any open figure, and if you leave that working, it's going to try. You're going to get 2 copies of everything, or 1 or 0 copies. It's all a mess. You can make it work. It's not that hard, but it is very confusing. So anyway, apart from that one caveat, you should be able to put things together and make panels now. But what we haven't talked about is how do you do all the cool stuff that you want to do? How do you make sure everything's linked up to everything else? Now that's more tricky. And so that's what the next tutorial is about. So now we've moved on to the exercise 3. And we'll use that same data set. The first example actually doesn't use any data set at all, but just to make sure it's loaded, it's up there. So before we showed an example with interact, and we got a widget, and we got a thing, and we're able to combine and mix and match and put other things in there with that widget. But how was it that that widget was connected up to that thing? It was through the magic of the interact function. Sometimes that works, but it's very coarse. Basically, interact, every time it changes widgets, it's going to run this function. And if you have an enormous data set and you only need to look a tiny bit of it, and it has to run a very expensive function, it can be very slow, it's very limited. It's great for what it does, but it's kind of a dead end in other ways. So once you've reached the end of what it can do, this tutorial is about how to go further. If interact already solved your problems, you don't need any of this stuff. If you can write a function and you're comfortable with that function being run every time someone touches a widget, you're done. You just need the previous tutorial. You can make all the dashboards you want. You just use the interact function. You write a function that returns the thing you want to see, and the arguments to that function become widgets, and you're happy. This is for when you're not happy. If you're not happy, you're going to want to explicitly instantiate a widget. There are all sorts of widgets. In this particular case, it's a color picker widgets. There are lots of widgets. A color picker widget, this just uses your browser. So this will be different on every browser. On Chrome, this is what it does. It lets you select on this rainbow. Other browsers will do different things. It's an HTML5 standard thing. The existence of it, but the operation of it depends on your browser. So let's say you've got a color picker widget. Now we need to really talk about what it means to be a widget. A widget is a thing with a control and an underlying value. In this case, the underlying value is this pinky color that I came up with. Let's make it a very clear color that's very close to red. So if I look at this value, you can see pure red would be FF0000. So I did a pretty good shot to hit that with the color picker. And so you can read out, so if you've got a widget, that means you can read it out in Python, the value, and do whatever you want. Now, so that means that you can have some widgets at the top of your notebook and then just use their values. That's one valid way to use this. To write a notebook, put some widgets at the top, people do some stuff, and then you execute the remaining cells. That's allowed. That's not a unified app, but it's super easy to do. So for any widget, you can do that. You can also change the value. If you change the value, so this is reading the value of the widget, changing the value of the widget will automatically respect that. This is all reactive. So it has a value and it has a watcher on that value. So whenever the value changes, the watcher is executed and it updates all the way. So all of this happens automatically from just being a widget. But you hope that the widget will do something. So in this case, well, it's out of range, but let's say here's a widget, and now the widget has been connected up so that it controls this HTML block. How do we do that? We can see that it works, right? Even though it's in a different cell. None of this cares what cells, because fundamentally this doesn't depend on Jupyter. It depends on Python. So it works the same inside and outside of Jupyter. The fact that these are in different cells has no bearing on it. It doesn't really mean anything. If that cell has been executed, that object exists in Python. And if it exists in Python, any view of it will be updated. So in this case, what we've done is we created an HTML pane that consists of just a background color, 100 by 200, that's this thing. 200 by 200, sorry. Looks very square. And then we did this command to link them. Now this is a Python-based link. There are also JavaScript-based links that'll survive and export, but this particular one is a round trip via Python. And it says whenever this thing changes at the browser level, go to Python and notify this other thing, and then it'll update this other thing. So it goes via Python. And so we've told it to link this object. The value of the color picker should be linked to the background parameter of the HTML. So I keep using the word parameter. It actually is, that's in capital P. There's a very specific thing that is called a parameter. It's from the param library. And this particular HTML object defines, actually we can probably do that. So if we do help on HTML, we can see that it has various parameters. It's going to give you a long list of parameters, one of which I hope is background. Yes. There's a background parameter defined. HTML has lots of parameters you can change. The height, the margin, the maximum height, style, sizing mode, all sorts of things. One of the things you can change is the background, which in this case is the background color. And what we're saying is take the background parameter from the HTML object and use it to set the value parameter of the color picker object. Does that make sense? It's super confusing to track everything down. But at bottom, all it says is take this bit of one object, connect it to this other bit of another object. So that whenever we change the value here, it will update the value in the thing that I just covered up, which is right here. So because I updated it here, this gets updated. That make sense? So this is a super easy way to do a straight pass. So you've got a widget, you can connect, and something else, you need the value of that widget to go directly to something else. You just say link, and that's it. Okay, so the exercise is to do that yourself. So it says start out with pn.widgets, widgets, and you have to spell it correctly, and figure out another widget. Float slider is probably good. If I do help on that, you'll see that help slider has a lot of parameters. So I could change the help slider's background color if I wanted to, same as that. But it's also got a value, and that's probably what I need here. So let's make one. Okay, this is a float slider, and it's got a value. So f.value initially is 0. Okay, so we've got a float here, and then if I ever look at the value, it'll be whatever the value is. Okay, so now we want to tie, so it's asking us to construct a string pane initialized to the value parameter of that widget. Okay, so I need that. A string pane, so the pn.pane. Initialized to the value, so it's f.value. Okay, now we have a string pane initialized to the value, which initially is 0. And then we need a link. Okay, this is where it gets confusing. So to try to do the right syntax. Okay, so we need to link the widget. The color picker above was the widget. So here the widget is called F. So we need to link the, do the link method on that widget. And we're going to link what the float has. Split cell. There. Okay, so if we, I better not do that. I hadn't finished editing that. So here we have a widget, and it's got some value. And now we're going to make a string that has that value in it, and we need to then update it to always not just have the current value, but to always be updated. Because right now it's not linked, right? I just initialized it to f.value. I haven't linked it to that value. I can initialize it to whatever I want. I happen to initialize it to the value of this float. So now we need to link it. And then we need to link this object. So not HTML anymore. This is now the S object. We need to link this object to, this is where I always get confused. So it was the background on the HTML, so I need the, I can't remember which, oh, that worked. Okay, so I linked the object, so my S, just to clarify what's going on here, so I have an S object, that's the string. If I do s.object, it's also that string. But it's actually just the underlying string, or the underlying float in this case. Okay? So the S object is going to be the thing that's displayed in that string pane. And so we have told it to link the S object's object parameter to the value parameter of this thing. And now things are connected. That make sense? I told you it was going to be confusing. I'm totally going to get myself confused every time I do it. But underlying it, the principle is simple. You just have to remember which item you need from each thing. So in this case, we want the object of the S thing to be linked to the value of the F object. Hopefully that just didn't completely confuse you. It's very simple.
Is that a one-way link?
Let's see. In this case, this is a watcher. So you can see what it returns here, actually. What is watching what? So it is a reactive link. So let's see what it would mean. So if we do f.value equals 0.87. So actually, I don't know how to answer that because I just updated the value, and you saw that the string updated. If I do it's a one-way link because if I did s.object equals, that'll update it, but it won't. Now it's, so it can't go in the other direction. Hopefully that I think that answers your question. So, yeah. So it's a one-way link, but you can link both ways, but this is the one way. You have to be careful about circular links, of course. But if it's meaningful to link both ways, you can link both ways. Okay, so there's a solution, which is probably the same thing I came up with here. Yes. So I could have just peeked at the solution, but that's lazy. All right, so that's linking. Linking is great if you need to go directly from one thing to another. Great. That's super easy. But what if you need to do something else? What if you don't want to just link to something directly, but you need to do some computation on it? Like this says 4, you need to say 4 asterisks. The value was the number of asterisks, and then what you actually want to display is not the number 4, but 4 asterisks. That's some complicated, any complicated arrangement like that is going to need a custom function. How do you do that? Well, this is the hard way to do that. Interact was the easy way to do that, and after this we'll show you the medium way. Interact was brain dead simple. You write a function, it automatically does everything for you. This is the hardest way, which is you instantiate a widget, you instantiate a pane, you write a callback. Those are all pretty straightforward. The callback is written in terms of events, and in this particular case, let's just watch what it does. This is actually reproducing exactly what the interact function did in the previous one. So I'll step back with that because that way you know where it's headed. So what it's done is create a widget, show a little row of a data frame, and link them all up. So if you really want to know what interact does, you can see it right here. So what it does is we've got a widget. Interact just figured out you needed an int slider because it was an integer parameter. Then we needed a pane. That is going to be a panel. We did that in the interact case as well, is return this df.lock object. And then we needed a callback. And in this case, what it does is update the this object with a new result given the event. Now, what is the event? In this particular case, we're going to tell it to watch something, and so the event will be a change in value. So this is the very low-level interface. We're saying that the row slider has a watcher. The watcher is going to be this. This function should be called when the value of that row slider changes. So every time I drag this, it's explicitly registered a watcher, and when that watcher changes, it calls this callback. All of this was done for you with Interact. And with this, you can do anything you want. Anything can watch anything and respond in anything in any arbitrary way. It's also kind of difficult. In this case, it's not too bad. But what if you have lots of interlinked 50 widgets here controlling 50 different things and everything's all together? That's not too straightforward. So what we actually recommend is, number one, use Interact if it solves your problems. Be happy. Go away with one line of code and go about your life. If it doesn't solve your problems, consider this approach, which is an in-between approach, which is, again, create a slider. Again, create some, write a function that returns the thing you want to see. In this particular case, it's a different example. I could have made it be the same example. But this particular one, it's a link. This could have been just done as a link, except that it's not a straight link. It's a link with a value of a parameter transformed by adding these few characters on top. So you could obviously put any arbitrary Python code you wanted there, and it would still work the same. And so what we did here is the same as in the other cases, but we have this one little thing here that kind of handles lots of complicated interaction for us. What it does is declare that this argument depends on the value of this. It doesn't say it's linked to it. Linked to it would mean you copy it directly in. It doesn't say that. It says that you depend on it so that if it ever were to change, you need to rerun this code. That's all it says. So you can make an arbitrary little function here to do whatever you like. So it's very similar to the linking case, but it's also fully, the syntax is very similar to the linking case, but it's completely general and can do anything inside that function. And so now if you do that, then you can have something, and you can have something else linked to it in a general sense, which means in some way is dependent on some transformation of that value. That make sense? Okay. So that's as far as we get in this tutorial. You can see that the thing that was created is, as always in panel, a row of something or a column of something. In this case, a text input widget and a function. The function captures this little callback here. Okay, so you can do this little exercise, and then I can't remember if at this point there was an exercise. Yes, so do that little exercise if you want, and then move on to exercise 2 which is in the separate notebook here. It's the second part of the first exercise. And I'll give my voice a break for a minute while you look at that. Okay, so hopefully you've gotten hopefully achieved something. If not, maybe not with all the things you might want to have done, but at least something, hopefully. So it's time to take a different tack now. So, I'm just trying to write down the actual timings that we had to put them properly in the website. Okay, so we'll take a step back. We could have done this in the other order. Basically, what we did was basic panel, things that are not to do with plotting, and we're about to do plotting. We could have done it the other way around. We could have jumped immediately into plotting. Our thinking we went back and forth, but our thinking was everybody, no matter what plotting library they use, can use what panel offers, and it's going to be something they didn't already have. Whereas this is going to tell you a great way to do plotting that is the basis for further deeper dives. But you don't have to use this way, but we have to choose something, and we're going to argue why this way is appropriate. But the panel will work with any tool that you happen to choose. Subject to the IPyWidgets ones still needing a little bit of work, but anything that's not IPyWidgets based at the moment should work. Those you would have to convert into something displayable like SVG or HTML or PNG. Then you can still use those tools. But if you wanted it as fully live IPyWidgets based things, that's not currently supported. But apart from that, you can use anything you want. And here is one thing that we would recommend that you, if you don't have any opinion about what plotting tool to use, we recommend doing this. And we'll tell you exactly why. So how many people have used Pandas .plot? If you have a data frame, you do .plot. Okay, that's why. That's why we're going to say to use this, because so many people have tried it. It's easy to do. I argued recently in print that it is now a de facto standard for plotting APIs. The pandas.plot API is now supported supported by Pandas, it's supported by Xarray, our own library hvPlot that I'll explain, a competing library called Pandas Bokeh that gives you bokeh objects directly. Our object will give you bokeh objects, but via other libraries. And then cufflinks will give you plotly-based plots. PDVega will give you Altair-based, Vega-based plots. All of these things use the same core API. And so why does that matter? Well, that API is pretty compact, succinct, and does a lot. So that's good. As APIs goes, it's actually a decent API. It's not terribly limited and locked down. You can do a lot with it, and it's pretty concise. So you can get a lot of things done using this API directly. And number two, it's not a dead end for you guys for learning. If you learn this API, and tomorrow you don't want to have the standard.plot PNG matplotlib-based output that comes with Pandas, you can load cufflinks and immediately get a plotly plot using the same code you already learned. So if you're going to if you worry about the space in your brain, this is a good thing to put in your brain because it gives you power later instead of locking you into something. Anything you learn and you become an expert at, that's great, but it also sort of locks you down to that thing. If you learn this API, you're not locked down. There are quite a number of possibilities available to you, and Pandas has actually just now officially recognized this, and they're putting in a formal way to update the plot interface with other backends. I don't know if that's released yet, but it's been merged anyway over the past month or so. And so I expect that will be an ongoing thing that data frames just have and support .plot with lots of different possible plots you can get. Moreover, this particular API, if you use our particular approach, can be used not just with Pandas data frames, but with lots of things. So that's another reason why it's useful. So again, we'll use this earthquake data, but now we're actually going to start plotting some stuff. So it becomes more fun. But remember the cost. You have to commit to using this particular library as opposed to Panel, which is just completely and utterly general. All right, so here's the data frame. Before we were ignoring almost all of it. Here we're actually loading in all the different columns. You can see that there's a lot of data available. The ones that we're going to use, I think, are the magnitude of the earthquake. Well, this is not just earthquakes. It's called the earthquakes data set, but it's actually any seismological event. So it could be an explosion or just something that shows up on a seismograph, whatever that is. And so it has an index. It has a nominal depth that's fairly hard for us to interpret. There's a place. This is a human readable place name. That's useful. It has a time where it was located, a time when it occurred, and a type. Most of them are earthquakes, but there are lots of other things too. Okay, so that's our data. And like I said, it already comes with Pandas to use plotting. There's a .plot interface that comes with Pandas. This is what you get out of it. Here we said you can just do .plot, but you'll get a line graph usually. In this case, these are just isolated events, and so we don't want them connected up. And so we have to tell it a little bit more information and say that we want a scatter plot. Although in our terminology, this is actually should be a points plot. A scatter plot should be when you have an independent and a dependent variable. We'll get to that. Anyway, this is, if you tell it scatter, you tell it X is the longitude column of this data frame. There's a latitude column and a longitude column. You say the X is the longitude, the Y is the latitude, and you tell it you want a scatter plot. In one line of code, you get a plot. So this is the standard things. It ships with matplotlib. So Matplotlib has got a lot of possibilities. Matplotlib supports lots of backends. This particular one is highly limited. This particular one is an image. So if you just open the image in another tab, you'll see it's just an image. Yes.
Point that percent Matplotlib notebook exists.
Sorry.
If you do percent Matplotlib notebook, you put an interactive figure.
Yeah, I was about to get to that. So representative of Matplotlib joins in there. So this particular one, by default, is a PNG. And like I said, Matplotlib has lots of backends. Matplotlib supports a dizzying array of things. And over the years, there have been various interactive options available for Matplotlib. At the moment, if you were to, so I haven't tested it in the same notebook with anything else, so I'm going to have to rerun things. But Tom was just suggesting doing to get an interactive plot out of this, which might need to rerun. And the creation of this is one of the reasons for the fact that there's now this interactive one that's currently supported is great, because this is now this is another reason to use the .plot API. People care about this API. They're going to continue supporting it and continue adding new things. There's also, so this particular one, you'll notice these are the interactive controls you'd get from Matplotlib if it were on a desktop. But now using this, particular way of invoking it, all we changed was inline to notebook. Inline does it as PNG, notebook does it as this interactive figure. So you can see it's interactive, it does that. You have the ability to pan around and so on. So, but we won't be telling you about that, because what we're going to tell you is things where you can link everything up to other, between plots and so on using this. But largely the same commands for invoking the plot will apply, so that's why it's not a waste of time for you to learn it. Okay, so in this case, the API changes just a little bit. We decided that by default we didn't want to overwrite the .plot command so we called it .hvPlot. Now the new Pandas support does overwrite the .plot command when you register it directly, and at some point when that's settled, we'll probably use that. But for the moment, instead of typing .plot, you do .hvPlot, otherwise the same API. And so you can compare the results here. This is an interactive Matplotlib notebook output, and this is an interactive bokeh plot. You see it from the little symbol here that means bokeh, and this is a scatter plot. Same command, same results. The information necessary to create these things is available in the data set, and you can just display it in this way. And so similar panning and zooming and such. But then we'll go a lot further and show all of the things you can do once you have this bokeh-based representation. Before I do, I just want to point out that this is quite an ugly plot. This particular default one, it has a bunch of overplotting. You can't really see any of the data involved there. You don't know if this is 1 million or 100 or whatever earthquakes in that area, and so on. And there are ways around it. Before we do, let's just play around with it just a little bit, see if we can make it be a little bit less overplotted. So in this case, we're changing the transparency. This API is the same between hvPlot and .plot. You have a lot of options available to you, and if you have tab completion here, you can find out what those are. There are a lot of them. So you can fiddle around with those all you want. And you can get different types of plots. I'll just let you play with that. But like I said at the beginning, we wanted to make sure that you can just see things for immediate exploration. Going back to the original thing, we're talking about the stages of plotting, the stages of the life cycle of data. When you first get something in, you don't know what quality the data is, you don't know how noisy it is, what weird outliers there might be, just you don't know what's going on in it. And so we tried to make it be possible to show it to handle any size of data and just give you a dump of the data. In this case, I didn't mention, but we are taking a subset of the data so that things don't crash. I can't remember where that is. There we go. We're taking 1% of the data. And that makes it safe to use just about any plotting library that works well with either the PNG or this interactive version from Matplotlib. And it works well with bare bokeh. That 1% is fine. And this is what happens if you use Datashader on that 1%. No, not that one. This is what happens. And I said earlier that Datashader is a way of doing server-side rendering. Basically, it's taking all of your data, arbitrarily large, keeping it in Python, rendering it to a fixed-sized raster, either, in this case, all the way to an image, and then embedding that image in a plot. And there's an experimental, the way these tools work, that will work with a bokeh backend and a Matplotlib backend. There's also an experimental thing from several Scipys ago where we started putting a native Matplotlib interface to the native so that it would work in cases like this, but I don't think we ever, I didn't ever go anywhere with that. I don't know if you did. Okay. So someday maybe.
It's an open pull request on data.
It still is an open pull request, yes. Anyway, this stuff is not open pull request. This is properly done. And if we run this, it's, if I import the one before it, this is actually using the full data set without any subsampling. So Datashader pretty much doesn't care about 2 million points. That is nothing to Datashader. As I showed at the beginning, 1 billion points, that was fine. 1 million points, no big deal. 2 million points, no big deal. Because it's all happening in Python. Python's great. Python has Numba in it. It's got Dask in it. It can do number crunching all you want. It's not limited by web browser tabs and different browser versions or anything. It doesn't care. And so you can just easily render it. And this is with no parameters. It's just a dump of whatever's in there. And also, if you zoom in, it's dynamically updated as you zoom. So it shows whatever the data is that's available. So apparently, you don't want to live over here. There's a lot of earthquakes. Oh, but maybe it's exciting. I'm not going to do this, but it says the next exercise is to try to run this without datashader equals true. I don't want to see what happens because I have to give this tutorial. So it probably is just going to kill this one browser tab, and it's probably fine. If I reload it, it'll probably be fine. But I don't want to risk that. I want to be able to keep teaching the tutorial. So you can try it if you want. Later, probably. Because what's going to happen if I turn datashader equals false? Well, this is bokeh. And the way bokeh works is, like I said earlier, it has a little bit of JavaScript running in your client. Bokeh is running in, there's the corresponding Python code. If I turn that off, what's going to happen is that hvPlot is going to create a bokeh plot, and it's going to encode all of the data, pass it down into the browser, and ask the browser to create an individual glyph for every point. And number one, that process of transferring in the browser is going to take a long time. It's optimized. It's a binary. Normally it'd be JSON strings. It's actually optimized. It's binary transfer. Maybe not too bad. But then it all has to exist in the browser's memory, and the browser is going to decide something's gone wrong and kill itself. So you don't want to do that. All right. I did say that was the .plot API is great. There are a couple of problems with it from our perspective. That we actually have a separate type for a points plot. Now they look the same, but they're very different. In a points plot, there are independent x and y axes, and together it's 2 dimensions specifying where is your data, and then the third dimension is what is your data, like is there a point or not. That's very different from a scatter plot with a dependent variable where you have x and you find some scatter about a y value. Now they look the same, but there are all sorts of things you can do with one of them. Basically, you need 2D coordinates to select if it's a points plot. If it's a scatter plot, you need 1D coordinate to select. Only one of them is independent in a scatter plot. 2 of them are independent of points plot. This is inherently, there's nothing special about latitude versus longitude. It should have been a points plot. Dot plot doesn't support points, it's only scatter. And that's fine because it looks the same, but we actually support lots of things you can do with it, and it matters going on whether you've declared it as having 1 or 2 independent dimensions. So we offer a separate one, separate from scatter. Scatter is useful, but so is points, and points has 2 dimensions. And then the third is, in this case, how many earthquakes are with that particular pixel. All right. So just to go on a little bit, here it's still using that matplotlib notebook, and so it's going to be this format that looks very familiar to matplotlib desktop users. Here, let's get a, just to illustrate some other things you can do in the .plot API. This is using matplotlib backend. .hist, you get a histogram over magnitude. This is all the frequencies of, and it shows that magnitude 1 is very popular for earthquakes. Magnitude over 7, which is happened this week in California, relatively rare, so it's newsworthy. You do the same thing when in .hvPlot. The defaults happen, well, it's not the defaults. We've specified how many bins, so it looks different, but it's plotting the same data. It's still a histogram plot. And again, it's got the interactive features. And we can do a kernel density plot, just so you don't have to guess what the syntax for that is. I'll do it. That's a KDE. If I try that, it's going to fail because it doesn't have those options. It's not a histogram. And then it has to compute a kernel density estimate. Essentially, that's going to smooth this plot, give a approximate continuous distribution, subject to many assumptions that I won't go into. And there are various other options like that. So you can find all about them at hvplot.pyviz.org. And the general rule is if it's supported by pandas.plot, it's supported in hvplot, but not always the other way around. hvplot is a superset, provides a lot of additional functionality. So if you really care about having something that'll only work with lots of different .plot libraries, read the pandas documentation and then go from there rather than the other direction. But if you want to know everything you can do with hvplot, start with the hvplot documentation. All right, this is the next few things. Actually, I don't know if this is supported in the .plot, the standard one. I suspect not. But in this case, this is going to show you if you can do what's called by and .group by. These are very similar keywords, but if you look, the results are very different. And these are very helpful for when you have some categorical variable and you want to look at how that is associated with the different subsets of your data. So in this case, let's take that histogram, but instead of using the histogram of the entire thing, let's first divide it into classes by depth class, and then look at those 3 different histograms. In this case, the default is to overlay that, and if you overlay that, you can see how everything relates to each other. Okay, so that's another thing that's available. And I know this particular one is not going to be, that one might or might not have been available in .plot proper. I really can't remember. This version with group by is not, because this one will give you, this particular one will give you a widget automatically, because by will do an overlay. Group by will give you a widget to select. They do the same grouping, but they give you a widget to select which one you see. It's kind of similar to the way difference between row and tabs in panel. Now note, someday this stuff will all be based on panel. Panel happened many, many, many years after this was written, and this is an independent set of widgets and libraries. So this is not a panel layout, and it's not a panel widget, unfortunately. Eventually it will be, hopefully. So this gives you an automatic way to get something kind of GUI-like, but really it's just capturing a data set that happens to have more dimensions than are available on the screen. If you have this additional dimension depth class, what do you do with it? Well, with this API, you can either overlay that when you go to by, or you can put a widget to select between the two. This is just to give you an idea of how deep the .plot API goes. What sort of things can you invoke with it? And then the last bit for .plot is just to show a heat map, magnitude class versus depth class. In this case, we're going to bin it by different depth categories to make it categorical. And then essentially this is a heat map or a 2D histogram by these originally numerical values. And effectively this shows that the shallow and light class is very common. The higher magnitudes are very uncommon. We saw that before already, though. Okay, make sense? So this is the tip of the iceberg. There's a lot available both for the standard .plot and also an additional lot available for hvPlot. If you go to hvPlot, so there's I don't think there's a gallery right now, but there's a user guide, and essentially you just choose whatever you want to, however you want to break up your data and explore from there. So this is all basic plotting, pretty similar to what you can do with the standard plot, and then we'll use this. This is one way, and that's what we'll use in the next section for as things that we can connect up and start to do the cool things you want to do in a dashboard, where this affects that and that affects this. So up to this point, it doesn't matter too much whether you use the hvPlot version or the Matplotlib notebook version or the Matplotlib inline PNG. They have similar affordances. But in the next one, we'll connect everything. And again, that requires committing down a certain path. And so we're trying to do this committing late in the tutorial. So that everything else is still valid, whether you agree with going down this path or not. All right, I think it's been, well, let me just see. Did we schedule a break there? No, we said you could do it. Okay, so unless somebody objects, I'll go there. We only allocated 10 minutes for this. Actually, it was supposed to be 20 and 20. I don't think that was updated. But let's do this and then have a break after that. So, because basically, this is what makes it pay off. Lots of ways to get individual plots, but you have to really deep dive into particular approaches once you start tying everything to everything else. So let's read the data again. We're in tutorial 5 now. I haven't really talked about it, but here we're using a Dask data frame, not a Pandas data frame. hvPlot doesn't care. hvPlot is supported for both Dask and Pandas. Pandas offers .plot. Dask doesn't have .plot. So it's just, it could. It hasn't been supported for it. So, instead, but hvPlot does support it. So we happen to be using a Dask data frame. You can ignore the difference mostly. It will make very good use of the cores available on my machine. You can use additional distributed resources, and that's all good. But for the purpose of these tutorials, we're just going to treat it as if it essentially is like a Pandas data frame. All right, so let's take our data and then slice and dice it in certain ways, and then we'll show how because you saw the original data frame. There are lots of columns there. It's very long and it's also fairly wide. So there's a ton of data in there. How can we put it on the screen for a human being to appreciate? You're probably going to have to take that multidimensional set of data and slice and dice it to show certain views of it, certain aspects of it, certain aggregations of it, or subsamples or something, so a human can appreciate. You can't really appreciate a however many, so 15-dimensional data set directly. So in this case, let's just break it up by time. There are a lot of events and one of the columns is the time column. So if we aggregate that over time, we can resample it. You can follow the code here, or don't worry about it. Just the data's in there, and we get a plot out of it. And the plot is returned from hvPlot, and it's just a plot of a set of counts over time. Very straightforward. Okay? So let's say we have a plot over time. Now what did we get? Now we have to start getting a little bit diving in. I said we were using .hvPlot, and we got an interactive bokeh-based plot. But what did we really get? Just like with interact, if we called interact, we got a widget and we got an app. What did we really get? Well, we printed it and we saw what was in there, and we were able to do certain things. We print this one, and we see that it is this weird notation here. It is something with one independent variable and one dependent variable, where the thing should be connected up. This thing that got here, I guess I assume we can type it. It's a HoloViews object. Now, I don't know if I've mentioned HoloViews. It was in the very beginning. hvPlot, the HV in hvPlot stands for HoloViews. HoloViews stands for view everything. Anyway, the HoloViews is a library significantly older than hvPlot. HoloViews does not use the .plot interface. hvPlot is .plot to generate HoloViews objects. You can generate HoloViews objects on your own if you want. You're going to have to learn the HoloViews interface, and if you love it, I love it, you learn that. But you can use HoloViews even without learning it if you can use .plot. If you can use that, you can use hvPlot and get HoloViews objects. So here's a HoloViews object, rendered with bokeh, created with hvPlot, and you can work with it. Okay, and this particular one happens to be a curve element. There are lots of elements. You go to holoviews.org, tons of elements. Line, heat map, whatever. So this is one plot. Let's just get another plot so we can compare them. This is the monthly mean magnitude. This is the monthly count. And so over time, this is what's happening on the planet. In that particular time on our planet, there were a whole lot of events. And at that particular time, the mean magnitude of those events was low. Okay. They're fairly hard to understand separately. They're both curves. HoloViews supports something called the plus operator. The plus operator does layout. This is similar to a panel row or column, but like I said, it predates panel, and it would be great for that if it just was a row or column. It is not. It is a HoloViews layout. It is usable as either a row or column. In this case, we told it to be a column. And it works kind of like a panel layout. It allows you to put multiple things next to each other. But unlike a panel layout, it knows what's in there. Panel is very agnostic. It just says, I'm going to put this thing of a certain size next to this thing of a certain size, and that's all it knows. Anything else is up to you if you want to link things in any particular way. HoloViews knows that these things are linked, so that if you were to drag one of them, it's going to drag the other one because they share an axis called time. If you don't want that to be linked, you can explicitly make it not be linked, or you can rename one of them. But it thinks that if you put things in the same layout and it has the same axis, those should be linked because they're presumably the same axis. They're a shared index between these plots. So HoloViews makes it easy to lay things out in a fully linked up way automatically under certain assumptions. And if you look at this particular pair of images, it's kind of interesting. I don't know anything about earthquakes. I do notice a couple of weird coincidences. I don't know. This is a very big drop in the mean magnitude and a very big spike in the count. So when there are a lot of them, they tend to be little in that case. And the same thing here. But then here's, so those two peaks are very high. What about this one? Well, that spot there also a high magnitude. Well, I don't know what that means. But you can certainly see them, and because they're linked, you can explore relationships like that very easily. Like, if I knew anything about earthquakes, I'd be able to figure that out. But I apologize to my colleagues who actually study earthquakes. Maybe you could correct me on that. Okay, so let's see, monthly count plot. I don't know what there is. Jean-Luc, do you write this? What am I supposed to explore about monthly count plot? Okay. I can't remember who wrote that, but
I wrote that.
where are you?
Just see that it's a HoloViews object and loads of different things. If you go to the hint, I think there's some.
I should have gone there. Okay, it has lots of things in it, but I don't know what. Most of those are not useful to anybody. But data is. I know what that one does. That's your data. In this case, it's a Dask object. And that's your actual data. That's a key thing about a HoloViews object compared to other approaches. HoloViews actually is not a plot. The thing that you got back is something that displays as a plot, but it is not a plot. It is a wrapper and an encapsulation of your data with some metadata that describes that it's sufficient to make a plot. That's a mouthful, right? A HoloViews object is your data wrapped in something plus some metadata, and that whole thing, if it's returned by a Jupyter notebook or displayed in a Bokeh server, will be a plot. But it's actually your raw data. It's in there, and you can always access it, always work with it. Table presumably is just another way of showing that. Yeah. Yes.
When you're using hvPlot straight from the data frame,
Yep.
it's just making guesses about the HoloViews metadata.
No, yes and no. It has defaults and it has a long series of options. So if you have data frame dot scatter, you have to supply X and Y so it knows what the columns are, and you can supply all sorts of other things. You can all sorts of other parameters you can stuff into that dot plot call. So basically, the dot plot.
Pulled back out into the metadata.
That's right. Those things, whatever you provide to hvPlot, has some mapping into an underlying HoloViews object's parameters. I mentioned parameters before. HoloViews objects have parameters, and those will either be, the things that you supply will either go to that HoloViews object's parameters, or even in other cases be passed directly down to Bokeh or the underlying backend. So the hvPlot API the HoloViews API is very clean, and it's very clear what happens to each one. The .plot API is more pragmatic. It's just all stuffed in there to make it be a one-line convenient thing. And some of those things end up at different levels in the system. But whatever, there are some things you can specify in there. HoloViews has its own option system. Whatever you get back, you can still modify it and change it at that level. So most things are easy enough to do with the .plot. But again, when you reach a dead end, when you reach a stopping point, it's not a dead end. You can always drop back and fiddle with things. You can say, oh, what is this thing? I really want to change the axis label. Where's the axis label option? There's no, I don't even know if there's an axis label option, but if there isn't, you can still change it. You can go drop down one level and figure out what it is in the HoloViews object and change it there. Once you've got a HoloViews object back, you can fiddle with it whatever you want. So that's kind of the point, and we're going to fiddle with it a lot here. So, I've switched back to inline because it's a different notebook, but it can be Matplotlib notebook, it doesn't matter. And then we'll do the same thing with .hvPlot. In this case, we're selecting only the most severe notebooks, and we're passing in something that could have been a HoloViews option. Here we're using the .plot API. We're telling it the third dimension should be magnitude. Use that for color. So map do a scatter plot of longitude versus latitude, where the z-axis or the color axis is magnitude. And you can look at the results and you can see that you got a scatter plot. See, this is wrong, right? It's saying that the independent dimensions are longitude and the dependent ones are latitude and magnitude. That is incorrect for this data. The actual dependent ones are latitude and longitude. And then given the latitude and longitude, what is the magnitude? That's the independent one. So we'll fix that in a minute, is what this says here. First, let's point out a problem. The default color map happens to this one that goes from black to white. And that's a problem because the highest magnitude ones will then blend into the background. So if there are high magnitude ones, you won't see them here. So that's the problem. We need to stop that. So let's start messing with some options. Here we get a different version of the color map where it doesn't go all the way to white. You can look at all the ones you want. They're all here at that link. But we picked one particular one. And let's do it in reverse order so that the color that's close to the background is the low, and the further away from the background you are, the further the color looks from the background. That's a good general rule for a color map. If you have a background color, you want the high intensity ones to be very different from the background. So it was backwards, so we switch it. And then now this is what we get. So now you see that there are a lot of these low intensity ones, these low colors here, those don't jump out, and the few high intensity ones really jump out. That's exactly that's a good color map. The really important stuff should jump out. Everything else should be less obvious. Okay, so that's a good start. So we're starting to customize it. How do we do that? We actually customized a lot. Let's look and see what we did. Again, this is using the hvPlot API. We've declared its X and Y in magnitude. We said the hover columns should include additional stuff from the data. Let's try it out. What do we get? Okay, so if we're hovering over something, we now get the magnitude, which is one of the dimensions, and then these other two that aren't even mentioned, we brought, by default, the hover will show the declared dimensions, X, Y, and magnitude in this case, latitude, longitude, magnitude. And then we say there are a couple more columns, put those in the hover. And then when you do, you get the place and the time. And then we say that we want a different color map, and then we say we want a different title. So all of that is now customized in here. This is all something we could achieve with the hvPlot API. There are other things that we couldn't. If we need to, we can back to that. But these are the sort of things that you can achieve, and those will go back and forth between the different .plot APIs. Okay. And we also use .points instead of .scatter. And now our dimensions are set up properly. 2 independent dimensions, 3 dependent dimensions. For a given location, there was an event. And these are 3 things associated with that event: the magnitude of it, the name of that, and the time of day it happened, time of history it happened. Okay, I don't think you have to do the exercise because we already did it. The exercise is just saying, pay attention here. This is going to show you what you can do with this data. So how you index it and deal with it depend on whether it was declared properly, and now it has been. This is just saying that you should we have to import it, and then this will give you a lot of different color maps you can choose from and decide. These are all the ones that are in the color set package. There are also plenty available from Matplotlib. There are plenty available from Bokeh, all sorts of other ones you could use. Okay, so we've been basically customizing and fiddling with things, and now we're going to start composing things properly, which is to put seemingly unrelated things together. So here's what one might think is an unrelated thing, which is a world map based on external map server. This is provided by the OpenStreetMap organization. If you keep zooming in, you get a new map every time. This depends on internet access, so it may or may not work for everybody. And then we can, this happens to be in a bizarre coordinate system called Web Mercator. We can Datashader happens to include a Web Mercator projection function. You can use whatever you want, but this one's available. And if you do that, you can project your data into this Web Mercator format projection for your coordinates. And so now you can overlay your data on top of a map. And the syntax for that with the HoloViews object is a star. It's plus for layout side by side or above each other. It's star for overlay. And when you overlay 2 things, they have to share the same coordinates. In this case, they're both projected into Web Mercator.
So when you scroll on that map, does the points, so like if you were to scroll to inside the, like, you're still not gonna display your,
Yeah, the tile, the map tile wraps around the points don't.
the points? Okay.
Yeah, they could, but it's what I'd rather do is just lock it so you can't go there. But we haven't done that. It's an open request. Because the alternative of scrolling, wrapping around eventually uses a lot of data. You have to duplicate the points all over the place. Okay. That's one thing you can do. That's a very useful thing, and it's just basically if you have geodata, you can always put it on a map. That's great. But you can also overlay with actual other data. So that's a map somebody else made and provided. What if we have data that we want to overlay with that shares the same coordinates of latitude and longitude, but is completely different data? In this case, we won't really get into it. This particular one is a raster data set. So it's a multidimensional data set. In this case, we're using two of the data dimensions, X and Y. There's also a band dimension. There are various other dimensions, I assume. Well, there's population. So we're using three of the dimensions, X, Y, and population. There are other, there may or may not be others. I don't actually know what else is in this data set. But in this case, those three are what's shown here. Population is shown as color, and we actually didn't need any arguments to that because those happen to be the default dimensions that have been declared for this Xarray object. So Xarray already knows about multidimensional data. So we can do .plot, and that's great, and that uses the standard matplotlib-based. And if we were to change that to notebook, we'd have the interactive one. And here, if we use instead .hvPlot, and we either pass datashader equals true or rasterize equals true. Now this is a subtle thing. Both of them use datashader. Rasterize turns your data into an array, a fixed sized array. Datashader turns that array further into an image. So if you turn it into an image before you pass it to the browser, that means the browser doesn't have to do any work and you can use all of Datashader's functionality. If you pass the array into the browser, you get things like a nice color bar and you get hover information because the actual data per pixel went into your browser. It's subtle. We have a whole notebook to explain the difference there. But anyway, if you see that, it means Datashader is being used. Your browser is actually doing this color mapping according to this. And that actually means you can there are some ways that you can dynamically color map. I won't even get into those. But in this case, we're using a log color map. There probably is a way to make this plot use a log color map, but I don't know the syntax for that. In this case, we are using the HoloViews syntax for that. So that's a little subtle. So look here, we had an hvPlot function returned. We passed an argument to that. That was the .plot API. We took the result of that and called a HoloViews function on it because we, in this case, know it's a HoloViews object. And we say, HoloViews, change this option. And then if we don't, it won't look very good. Because this is actually plotting the world's population, and most parts of the world are, the very highest populated parts of the world are very densely populated, and then everyone else is nearly empty in absolute terms. Where if you use a log scale, you can see there are lots of gradations there. Okay, so here we have some raster population data. Previously, we had tabular earthquake data. But because they share the spatial dimensions, we can overlay them. I probably think I should just skip this, but this thing that's right here is not just a raster, it's actually a dynamic map, which means give me a raster whenever I need it. And so that allows us to, for instance, dynamically zoom in and have everything recomputed. At some point it'll bottom out into the underlying available resolution, which is, I guess, happening there. But before that, you can actually access all of the available resolution interactively, because every time I zoom in, it's dynamically resampling the data, regrading the data, and presenting it. So that's what happens when you do rasterize equals true or datashader equals true. I think I'll skip that. Okay, so finally, let's compose and make things add up. Here's our final plot that we got by composing what we got from hvPlot from one data set from Pandas and what we got from hvPlot from another data set from Xarray. They are both HoloViews objects. They both have the same spatial coordinates, and therefore it is meaningful to overlay them. And so we have overlaid them, and we changed their title, and then we look at that. Okay? It took longer than I thought. So, all right, we need a break now. We will cover a little bit of this. We actually don't need to cover tutorial 7, so it's marked on there, but in the process of this, I've already covered nearly all of this material for it. So you can cover, we'll skip tutorial 7, you can do it on your own. It goes in detail for the, talking about the steps involved in dealing with this large data pipeline. You've already seen it in action several places in here, so it turns out this is largely redundant, but you'll see how to do that on your own if you want to. So we'll come back and we'll focus on the interlinked plots and advanced dashboards. You've already seen number 7. So we'll take a little break for, let's see, O2 back here at 4:10. Actually, do we have a bigger break scheduled? Probably do. No, they're all 10 minutes. That's all you get. 4:10. Sorry, that's all I get. All right, so there's 10 minutes for exercise 3. It's basically open-ended. You can keep working on that. How many people want to keep working for 5 more minutes just to play around with these tools? How many people are ready to move on? Small bias towards move on. And I've had coffee, so I can move on. All right, this is where it starts to get hairy, I'm afraid. It's designed to have the first part. If you walk away, you have something. If your brain gets full later, you still have that something. Now is when your brain will probably get full. For most normal people, if you have bigger capacity because you're more familiar with some of this stuff, you'll be able to handle it just fine. It doesn't mean there's something wrong with you if you get bogged down on this part. This is the part where the details matter because you're going to connect this detail to that detail, and those are eventually what you need to do. You don't have to be able to do it today, but this will show you that it is possible, and these are the steps to do it. Don't feel like this is not for you if you struggle with following every step involved here. That's normal. This is the point in the tutorial. Any talk will be like that. You start out, everybody's along. At some point, it's going to dive down into details that are going to lose some people. This is, hopefully, we haven't lost too many people yet. In that last one, it's okay if you miss some bits. That's totally okay. This one, if you don't miss some bits, it'll be weird. So, interlinked plots. The previous ones are interlinked by default. They're interlinked automatically on anything that matches up, and you don't have any. There's control on that. You can turn it off, but you haven't explicitly set that up. So what happens if we want to explicitly set it up to do whatever I want to? Dang it! That's this tutorial. And this is only about plotting. It doesn't mention anything to do with panel. And then the next one is basically bringing it back into panel. This tutorial is just you've got some plots, and they can be linked with other plots. And the next one, the final one, you'll be able to link them with anything that panel supports. So again, we're working with the same data set. Again, we are cleaning it up a little bit before we use it. We're projecting it because we're going to want to overlay it on maps. Again, we're taking the high magnitude events. They're not all earthquakes, as you'll see. And then we will overlay that on a web tile map. This particular one happens to come from Esri. And so we have our data. We didn't do anything about the hover columns in this case, so you can see it's just the default dimensions that are declared. The X and Y, in this case, these are properly labeled as easting and northing rather than X and Y. They're that's the units of the Web Mercator system. And then you can see that we ended up with a points object with these dimensions. This is all as it should be. There are 2 independent dimensions and 1 dependent dimension. And then we can look at the data inside, and we can see that we have our original data set. It's a subset of it because it's only the high magnitude, but it's all the columns that are available in the original data set. It is the data. It's not a copy of it or anything. It's your data set. That's just how HoloViews works. Okay, so now we're going to build up. This particular one was made with hvPlot. Now let's build it up from scratch as HoloViews, where we can control every little bit. So we'll go back to the data, and then we'll just skip that. Okay, so now let's. Now we're going to import HoloViews. HoloViews is going to give us a new API. Previously, we've been using the hvPlot API. Now we're going to use the HoloViews native API, and we're going to explicitly say that to use the bokeh backend, hvPlot defaults to bokeh, and pretty much at the moment almost entirely just supports bokeh. HoloViews supports bokeh and matplotlib, both quite with equal strength. Very good support for both bokeh and matplotlib, and then has plotly, which is lagging, which is a little bit newer, lags behind it a bit. We're working on it and bringing it up to as fully supported as bokeh and matplotlib. What is well supported in the plotly interface is all the 3D objects available in plotly, which is why we added it, because it offers things that are less well supported in bokeh and matplotlib. Anyway, we're going to stick to the bokeh one. You can change this if you want. And just give you an example of what the native bokeh HoloViews interface looks like. In HoloViews interface, you explicitly create a points object and you pass it in the data. Every HoloViews object accepts an initial argument, which is the data. That data could be a data frame. In this case, it happens to be a couple of arrays. And then we get a points plot. This is just toy data, of course. But this is, we could have done the same thing and wrapped this up as a data frame and called hvPlot to get this same object. This is using the native API. The native API has lots of beautiful theoretical properties. The hvPlot API is pandas.plot API, which is very pragmatic and concise. Doesn't have those same theoretical properties. If you go to HoloViews.org, you'll learn all about it, but you don't need to in this case. Okay, so let's. In this case, we haven't specified much information, so it happens to default to X and Y. We didn't actually tell it what those dimensions were. We just gave it some random numbers and some more random numbers. Let's give it a little bit more information. Let's give it a y-axis, give it a z-axis, an extra axis, which is the a random fitness, and let's label the independent dimensions width and height. And so if we do that, we can look at the result. Here we've got weight, height, and fitness. Jean-Luc, I'm not sure where this example came from, but anyway, it's an arbitrary example, but it allows you to specify multiple dimensions and build something up from the ground up. Okay? And dimensions are super critical to how HoloViews works. It needs to know what are your dimensions, your independent dimensions, and what are your dependent dimensions. Okay, for this exercise, I'll just take you through it. You can play around with yourself, or you can watch me, either one. Visit the HoloViews reference gallery. Just pick one. They look nice, and then try running one of them. So. The radial heat map looks pretty, but okay, path. Path is useful because path can be lots of things. Like this is a path, this is a path, and that is a path. These are all paths. So paths are basically interconnected points in a plane. So if we copy that example, and I probably have failed to import something. Nope, it works already. Okay. Okay, so and pretty much everything in here, these are all organized in terms of self-contained examples that are easily replicated. The one good and bad thing about it is that these examples on the HoloViews website tend to be done starting from NumPy. So this tried to be the bare minimum assumption. If you have NumPy, you can use them. It might be nice if we had a little Pandas button that you could click on and it would use Pandas instead, because most people don't want to start with NumPy. They want to start with something more familiar and more easily adapted to their own work. Because a lot of people use NumPy, but they don't know they use NumPy. They instead use it via Pandas. So here it's showing how to use it via NumPy directly. It works just the same via Pandas, but in Pandas, Pandas actually knows the name of the various columns. NumPy doesn't. It's just a couple of arrays. It doesn't have. They're not even in the same data structure. So when you use the NumPy one, you have to specify certain things. If we had a Pandas version of the example, it might be a little simpler. So in this case, if we wanted to specify the X and Y, we can't put them into NumPy. You have to create a Pandas wrapper that then stores it, or we can pass it directly into HoloViews. Ignore me if this doesn't make any sense, but it's worth knowing. Okay, going back to our example, when we first came up with this data, we said that it had a third dimension fitness, but we didn't tell it to do anything with that value. So there's the height and weight, and then there's just the location of the dot. That is not mapped onto anything visual. It's there, but it's not mapped in any way. So what if we tell it to map it onto the color of the plot? And we can also set some other options. These are all via the HoloViews option mechanism. If we do hvPlot, it's just a slightly nicer formatted version of the regular Python help. So if we do that, we can find out all the things that we could set options on. There are a whole bunch of options. These are all options that are passed directly down to, in this case, bokeh. If you selected the matplotlib backend, you would see matplotlib options here. So this section is things that go directly down to the backend, and HoloViews doesn't know or care what they are. They just say, oh, I recognize that. That's bokeh's job. Here you go, bokeh. So all of these will be passed down to bokeh. And then there are others that HoloViews does know about. It's a fairly long list in this case. But there will be things like the ticks, various sizes, various projection, how to normalize things, lots of options. So you can find out all about them, and you can also get you can find out what's there with .ops. Well, that's actually a little more complicated, so I won't get into that. But in any case, this is using the HoloViews native interface and the HoloViews native option setting interface. You can use this interface with hvPlot objects or with HoloViews objects. They're the same thing. hvPlot returns a HoloViews object. Here we've created one natively. The entire HoloViews system for customizing objects is available to you. And sometimes you need that if you really need to do something that wasn't anticipated in pandas.plot API. This is how you do it. Okay, exercise. Copy the line above. So what's going to happen there? If I do color equals blue, previously color was fitness. What if I do color equals blue? Okay, color is just blue. Then you'll get that. There are some very detailed issues discussing the ambiguities involved there, and the what should happen in those cases. And a lot of very smart people arguing different positions on that continuum. So, but in this case, height. So, basically, you can either. A string is ambiguous. Is a string a data dimension or a color? I believe it favors data dimensions and then falls back to color. I'm pretty sure, but that's been several years since I had that argument.
But you call it something before, right? So you could
You could change that. In fact, you can change the displayed value completely independently of the Python identifier. Those are, by default, they are the same thing, but often the displayed value will have formatting and equations and weird stuff in it. None of that matter. You can have them independent. And so if you did ever have a conflict like that, you could change the Python identifier and keep the same displayed representation. That is not a problem. There's a difference between a name and a label, basically. But you can still have a bug where you thought you were referring to a column, particularly if that column had colors in it, and you instead are referring to the color. So it can happen. All right, we already covered help. All right, so let's. I don't think there's actually anything for us to do here. We've already covered enough of the help here. You can basically figure out what this thing is. In fact, you can get a handle on it. Obj equals, and then you can see what is obj. No, you have to print it. If you print it, you can see what it is. It's an overlay of some tiles and some points. And each one of these are overlayable because they share these axes. This is one of the cases where it really matters whether you declared it as having one or two independent dimensions. When you try to overlay things, they have to have the same dimensions for you to be able to overlay. Otherwise, it's a categorical error. But as long as it does have the right dimensions, and you're able to, it has to have these dimensions have to map. The other dimensions don't have to, because you can map the points to anything as long as they're displayable in this set of coordinates. All right, so now let's, these are the building blocks. Now we're going to start connecting things up. I keep promising that. I know, but now it's going to happen. Okay, so let's connect it up first for a toy value. Here, we connected things up so that my pointer position is being reflected as a horizontal and vertical line. So these could have been separate plots. These, in fact, are in one plot. Now, what did we do here? We're using a concept called streams. HoloViews has a concept called streams. hvPlot does not know anything about streams. It uses it internally, but that's not part of the API to the user. Whereas it's an explicit part of, when you drop down to the HoloViews level, you have something called a stream. A lot of things in HoloViews work using streams. In this case, we've created a pointer XY stream, which basically will reflect the location of my pointer. And we have created a function that, given an X and Y pointer location, it will return a fixed ellipse and a horizontal and vertical line that depend on the X and Y location. So that makes sense? It's a function that, given a location, will return a HoloViews object. So if I just typed crosshair 0, 0, I get a fixed object. Make sense? Yeah, well, it's interactive, but it's not reflecting my mouse in any way. How did we get it to reflect the mouse? We connected the streams. So we created this object called a dynamic map I've referred to briefly. And we said we want to draw a dynamic map. Dynamic map just is it's similar to the panel examples, but again, like I said, HoloViews was designed before panel, and so it's not in terms of panel. So this is a similar concept, though. It takes a callback, so in this case, this function, and it's going to be connecting up the arguments to that callback with the results obtained from this stream. This particular stream happens to have parameters called X and Y. Not happens, that is what it is. It's a collection of X and Y locations. And it's one that will respect the X and Y locations of the pointer of the plot where it is used. So it's used in this plot, therefore it is tracking my X and Y locations of my pointer. And so in this call here, this is where we link things up. We say, this thing should be driven by this thing. This thing is a stream of X and Y locations, and those are to be used as the arguments to this function. Okay? This thing, if I do pointer XY, you can see that this is an object that has two parameters, X and Y, and they are named X and Y. And if we pass that in, if we change this to be something else, it's going to fail because it's trying to map x and y onto x2 and y. The name of it actually has to map. It doesn't have something to drive the x parameter. So it's it's actually noticing the declared x and the declared y parameters of pointer x, y, and it's mapping that into the declared x and y arguments of this function. Yes?
This might be too in the weeds, but a lot of APIs, this sort of thing, you subscribe the callback to the data source. Here you're passing the data source to the callback.
The panel depends operator that we showed earlier is of the other nature, where you annotate the function with, so basically you're describing the function, and that's the other way around.
Is that
I think Jean-Luc created a dynamic map, so ask him. He wasn't paying attention though. So yeah, you could do it either way. In this way, this dynamic map function is actually a generalization of another object called a holo map, which is where HoloViews originally got its name, which is like a dynamic map, but not dynamic. So a holo map is essentially a multidimensional data container. A dynamic map is a multidimensional data container where the data may or may not exist when you instantiate it. So it was a generalization from that, therefore it shares the same interface as a holo map, but in this case accepts instead of accepting the data, accepts a function by which to get the data. So it's following that. Whether that's a great idea, I don't know, but it works. And the result is, even though I messed it up, easy connection between a stream and some aspect, some function that returns something visual. So you can see that you could have written anything here in this crosshair function, and you can connect any stream. And what streams are there? Well, you can make your own streams. The streams are available, range X, Y. There's a whole list of them on HoloViews website. But there are streams, can be an incoming data stream, that's a stream, pointer position, clicking, selecting, interacting in any way with a plot. Those are all streams. So basically you can tie any sort of aspect of a dynamic input to anything that you can display. So as you can imagine, that's a very powerful approach. This is all based on Python, by the way. When I'm moving around in here, you see there's a little lag. Well, that lag is just the same as for Datashader. It's going to Python, computing some stuff and bringing it back into the notebook. This is not JavaScript-based client-side rendering. This is happening on the server, which is good and bad, of course. It means you can do any Python. It also means you're tied to that server. But that's the sort of thing we're doing. Okay, the exercise is to look up the definition of these elements. I think you can, that's probably something to work on in the context of a larger example. So those are things that you can try out. But basically, if you go to the HoloViews reference guide, you'll see all the streams that are available, where streams are down here. And so bounds, freehand drawing. Some of these are about creating data. You probably want to steer away from those for this purposes. That's fairly advanced. Getting the pointer location. So the draw and edit, those are the more advanced ones. Range, that'll be the plot range. Selection 1D, that's a very useful one. That'll tell you if you have 7 things, it'll be the index of one of those 7 things. So that's super useful. There's selection 1D and various variants of it. A tap will be where you've clicked in a continuous space and the nearest glyph. And yeah, so these are the ones that are already defined. You can also define anything you want. And essentially what that is just an object that has some parameters. It's up to you to set the values of those parameters. That's what makes it a stream, that something somewhere is changing the values of those parameters. In this case, it's bokeh.js is changing bokeh Python, is changing this object, and then that's inherited. Okay, so now let's actually do it with non-toy example. Those were all toy examples. First off, we're going to use a tap stream. To use a tap stream, we're going to use a selection 1D stream driven by the tap tool. The tap tool is this thing here. what that does is allow you to select or tap on a particular data point or glyph or collection. In this case, it's in isolated data points. So you see what that does? This actually is a little bit better if we can do a minor change to it. And then we'll look at this and then go backwards. First we'll see what it does and then go backwards to see how it does it. So we're going to use this tap tool to select a data point. And every time we select a data point, we want something to happen. So if we click on nothing, it goes back to an unselected state. If we click on something, if we hit it directly, it will pull that out into Python, look up use the index of that thing that I clicked on to look up the place name, and then it will put it on top of the map. Okay, it's clear what's happening, if not how to do it. So we're tapping, and we either hit something or we don't. If we don't hit something, we get an empty set of data. If we click on something and we hit something, we get this text element that says some information about what we clicked on. Okay, well, let's look at the code for that. So if we go backwards, we'll see that this is map tiles in the background. So that's the easy part. And then we overlay the high magnitude quakes. We turned on the tap tool because we need that. That's a bokeh option that just says add the tap tool. And then we're adding in the labeler. That's this text on top, or 0. You'll see. And then we added the hover information. It says tools as hover, but I don't actually see any hover information. Well, that may be just sitting around there. Okay, so how does the labeler work? That's the key that we have here. So let's work backwards to the labeler. Okay, so this labeler object, it's a dynamic map. Okay, great. That means it's something with a callback. There we see our callback. And it's something with a stream in this case. Dynamic map doesn't have to have a stream, but if it does, that stream will be applied to set the values of the argument of this callback. So in this case, the selection stream, which we defined here, was a selection 1D. What is a selection 1D? Well, if you have basically, if you have a columnar data set, that'll be the index of the value. There's only a columnar data set is defined by having, at some level, an index column, and that'll be the index of the data. So it's a whole bunch of data points. You select one. Yes?
Points with scatter. That's a mistake. The opposite.
Ah, that's what. It was correct, but the. Okay, that's why. So it was turning on the hover. I was confused because the hover was not appearing, but it's because the hover was being turned on for a type that is not in this image. This is a points image, not a scatter image, as it should be. It's supposed to be points, but the options also have to be for points for it to work. Okay, thank you. Now we're trying to figure out this labeled object. How do we get it? It's an overlay that will return something that is displayable, driven by this index. And so the selection 1D, that's super easy. Like we just specified, all we did is instantiate this selection 1D stream. It's sitting there, it's selection stream. We tell it that selection stream should be used for this function. And now this function is anything that can use an index. Now, if you think about it, if you have a data frame and you have an index, you can do anything you want. You could, when you click on it, you could delete that thing. Or whatever. You can pop up another plot. You can have anything you want happen here. In this case, what we're doing is we're going to overlay, so it won't pop up another plot. It'll be in the same plot. We're going to overlay a text element. That's what's being returned here. So that's what you see here. And the text element will be located at a particular location. The particular location will be at the, where is that? Okay, here we took our data frame. This is not the entire 2 million set, but it's a smaller one of most severe items. And we, actually a selection 1D can return a set of if I click when there are several overlapping points, this is a little confusing. So it's there are several overlapping points here. For instance, when I hover there are 2. And if I click on that particular location, I'll get back both indices. And so what we're doing here is just ignoring everything but the first index. And so that's what this first code here does. And so we get one index, and then we take that index and we look up the data associated with that. That's straightforward, right? All we're doing is, this is standard Pandas stuff here. And then having gotten that row, now we're going to construct a text element where we take the rows latitude and longitude, or easting and northing, and that's where we're going to put the text element. So the text is located exactly where we click, wherever that is.
You need to put the tab tool back.
What happened to it?
You need to put tab tool back in.
You're overriding it wrong.
You've overwritten it. You need to put the tab tool back in.
Oh, in this one?
Yeah.
I didn't write that. Don't blame me. Okay, there's the tap tool that had disappeared, which is why I couldn't locate anything. So before it was happening to work because it was setting on the wrong element. Now it's setting tap and hover. So when I click on one, it's taking the first one. You can't see it because the hover information doesn't show 112, unfortunately. But if it did, it should show that it's taking this particular top one, and it's showing that it's doing text located at that X and Y location that it found from looking up the row, and it's using text, which is the index and the place name, and it's doing the whole thing white. Okay, that was a mouthful, but it's actually not very complicated, right? Step 1, you click on something. You get back the index of that thing. You look up in the data frame some row of data, and then you use the bits of the row of data, construct some viewable thing, and return that. Every time it clicks, it calls this function and does that. Straightforward, hopefully.
Okay, so why do you have to specify tab twice?
I don't think this one's doing anything.
So you're overriding it off in the second part. You can do it. You can declare it here, or you can declare it down here.
Yeah, the first one doesn't do it.
This one works too. It's just you're overriding it later.
Yeah, the first one doesn't do anything in the final result because the tools, it has some value. So this is actually this is a side thing, but the bokeh plot has a set of default tools and a set of tools. The default, if you want to override everything, you have to set the default tools to nothing, and then you can put anything you want in the tools. Otherwise, what you'll get is your default tools plus whatever the value of the tools option is. In this case, we first set the tools to tap, then we set the tools to hover, and then finally we set it to tap and hover. That's what it always should have been, is tap and hover. But if you set it twice in the same call, it's briefly set to tap, and then it's set to tap and hover. So the first one had no effect, given the second one. First one briefly had an effect, and it was overwritten. Make sense? Okay. That's just a side note. Yes?
Can you just answer a couple of general performance questions?
Yes.
Based on what we were talking about before. So you're saying that every time you do this, it's calling the server, basically. So like if my server is sitting in Maryland and somebody in China is supposed to be accessing it, this is not going to work very well. Correct? Or am I
So just to really imagine it, right now everything's sitting on my laptop. But let's say this notebook we're running far away in China. Does that the definition of far away? Then fine, it's running there. And when I do a click locally here in Texas, the location of my browser, of my cursor in that plot, those two numbers are sent to China. The computation is done in China. And the bokeh object that corresponds to the returned value of text item is returned. Now that's actually a very compact representation. It's got maybe 10 characters will come back from China, and then that'll be displayed here. The pixels won't come back from China, just the 19 colon and then some characters will come back from China. So there will be a latency, but the total amount of data involved is low in this case, because the only thing that goes there are coordinates, and the only thing that comes back is whatever you want to display. And if that is burdensome, you can make sure that you can just use Datashader, and then the image of the data will come back rather than the copy of the data. So.
My second question would be, let's just say 30 people or 100 people, 300 people. A standard method would be I just have a proxy and I have a lot of like servers
You can use, if you go to the, so underlying this, because we're using the bokeh backend, is bokeh. And if you go to the bokeh.org website, you'll see all about proxy, reverse proxy. You can set up Nginx. You can do, if you have the money to pay for a server farm, you can set this up as you want. You can also, if you use Panel, you can have Panel capture a limited amount of interactivity, basically solve everything at the Python end and ship something that is pure JavaScript at the result and share that. So if you only need to choose between 4 options, or you only want to select between 100 locations, you can just package all that up, do what's called embedding, and then ship that out as static HTML. And then you can put it on any website and serve it. And you can also put in, if you really want to do that, you can put in custom, instead of having custom Python here, you can put custom JavaScript. And if you're willing to write 3 lines of JavaScript, it doesn't have to round trip to the server. That can all happen in the browser. So to do that, you have to learn some JavaScript, or you ask your buddy, hey, how much would it take to make you write these 3 lines of JavaScript? I can do it in Python. Can you convert that to JavaScript for me? And if that's fine, you can do it all without any server at all. But the whole point of any of this setup is to make you as a Python programmer able to exploit your data and your results and share them with the least trouble and the least pain possible. And so at the end, if you do want to dive in and have a huge impact from your results by making it fully public so everyone in America is seeing it at the same time, then you can do that. But we got you immediately to the point of being able to share it. At that point, you probably want to bring in a JavaScript developer, maybe go from there. But you can share it with a reasonable number of people very easily. You can share it with a fairly large number with a little bit of extra effort. And if you want it to be at a government website hit by millions, you probably want to do some more effort to really optimize the process of delivery. That's not what we're optimizing here. We're optimizing the process of creation. How hard is it for you to sit down in Python and make something great and share it with people? We care a lot about that because that happens all day long, every day. How often do you need to make something to optimize the delivery of it? That's much more rare, usually the outcome of a research project. But this is something you can do every day. Every day in your research, just, wow, share, immediate. So different tools for optimizing different things. Yes?
How accessible or easily accessible are some of the other axes objects in these plots? Like for instance, let's say with this tab, I click on one of the locations, and I want to put a line or an indicator on the color bar where that falls in the range. How easy is that kind of?
I don't think that there's this color bar object is a limited thing that actually Jean-Luc is working on expanding the definition of color bar. You could easily replace this color bar with a plot, which at some point we showed something that looked kind of like a color bar. I don't remember, over here. Each one of these things, if you put the axes and labels on, you can treat that like a color bar. So you can manually create a plot of a color bar and then do whatever you want. This thing here is not that. This is an extra thing that added by bokeh at the JavaScript level, entirely in JavaScript, and it does exactly what it does. And so you can't customize it arbitrarily, but you can easily replace it with something that is a plot. And then you can do anything you want. If you click on here, you can put a little marker over here. Anything is possible. So the answer is no for this particular exact thing. The answer is yes for anything you want to do. You'll have to invest in basically making a fake color bar that's really a plot. And then plots you can do anything with. Okay, I want to make sure to leave time for the exercise. So I'll skip this for the main exercise. So you can do this as part of your main exercise or not. Just wanted to get to the end of this notebook, which is largely similar to what we've shown so far, which is here instead of adding text, we're going to quite similar, driven by a selection stream. We're going to mark the earthquake's location with these little circles, just because that's typically how earthquakes are written on a map. And that shouldn't be anything new. It's also, if you zoom in, you'll see that it's actually selected earthquakes in a local area around it. That'll become important in a minute. So whenever you click on something, what it does is look in an area around it and select that particular set of earthquakes. And the reason for that is that we're going to try to explore different dimensions of data for the nearby earthquakes. So if we do that, that'll happen here. This is we'll try to skip over this. Hopefully it is not important because this is showing a way to speed things up by caching it. And then so just so we get to the end of this particular area so we can kind of show where it's going, and then we'll come back. Okay, so this is what we're trying to do, is to pull things together so that when we click on something, essentially what we've done here is to select, to figure out a single earthquake, then draw some circles around it, draw a label on it, that's in the same plot, and then to use that, the local region around it, to do a histogram of all of the nearby earthquakes, and then do a time series of all of the nearby earthquakes to show basically when something big happens. So let's try to find, in this case, it's back to the old color map where white is highest. So let's try to find something that's that is a does it? I see something bright here off Indonesia. So there's one. So let's yeah. So that's Indonesia. It's something big happened there, and let's just see what. Okay, there's the big one right there that happened, but there were a lot of what are those called? Prior shocks? No, these are aftershocks are over here. Pre-shocks? I don't know. Foreshocks? If I knew anything about earthquakes, I would know the answer to that. Anyway, you can basically study. Having selected something, this is what everybody wants to do, in my opinion, is you see some plot and you see something interesting and you want to drill down and dive in and explore. This is trying to capture that process. You saw something, it was a big event. You want to see what happened around that event. Here's the time series. There was, I don't know how far back the data goes, but probably to around here sometime. And then there was nothing, there was a whole cluster of things. It seemed to die down, and then suddenly there was a huge response. I don't know that there's any more before or after. People talk about aftershocks. I don't know, before and after seem similar. Anyway, these are a bunch of events in the general vicinity of this earthquake. And the line here is just marking the particular event that we've selected. So you can probably guess what the code for all this looks like, hopefully. It's the same code as you've seen before, just more of it. We're taking a map. We're overlaying the high magnitude quakes. We use the tap tool, not the hover tool in this case. We added a labeler, which is the text. We added a quake marker. That's the circles. I showed you the code for that earlier. That's this first plot. Then we lay it out next to a histogram, which is this second plot. And we lay it out next to a temporal distribution, which is the third plot.
Is your temporal distribution overplotted so you can't see the aftershocks?
You can zoom in. It doesn't look overplotted. Luckily, that's the great thing about interactive plots, is that you can answer a question like that without typing. It doesn't look like a lot anyway. Yeah. Doesn't.
It's like the scale is too small, so you don't have pre-shows. They're all too tight together.
Yeah. Anyway, excellent scientific questions. I don't know the answer. We were just talking about the plotting, and so for the plotting, you can imagine the code for histogram, the code for temporal distribution, the code for temporal V-line. We can briefly look at it, but you'll see they all have the same form. It's a dynamic map. It's driven by the selection stream. When the selection stream is updated, it's going to call this callback. The callback is going to somehow return something. In this case, a vertical line, this vertical line here. And every little piece is going to be another one. The scatter is going to return a scatter plot driven by that selection stream. The histogram is going to return a histogram driven by a selection stream. Make sense? You select something, you get an index back, everything else flows from that in a fairly straightforward way, which is basically the same way you build up plots in HoloViews ever, but in this case you're driving it from a stream instead of just some number you picked. So. All right. So that's it for interlinked plots. To keep things on time here, these are the parts that conceptually I would hope that everyone gets it. In practice, connecting things up appropriately, that takes a bit to realize, oh yeah, that is that parameter of that thing that I'm going to connect up. That's where it might sound nice, but when you try it, you'll get some struggles, and that doesn't mean you're stupid. It happens. Well, if it means you're stupid, it means I'm stupid, because it happens to me too. But if you play around with it a while, you can figure out how things connect up. You can follow the examples, and that's what you'll do in the exercise in a minute. Like I mentioned earlier, we don't need to cover this, and then we'll get to the last one, which is basically just setting you up for the exercise. So this one, I'll run it just so you can see the results, but we won't spend much time on it. This is just talking about how Datashader works, shows you how to build things up from the ground up, and how to use HoloViews interface to Datashader if you need to be able to combine it. That's a data shaded plot on top of all the earthquake locations on the map. This particular one is Datashader combines very nicely with HoloViews. You can actually see what all the different types. These are kind of fun. Some of the seismological events are earthquakes. There's also nuclear explosion or a rock slide. Acoustic noise. I don't know. How many nuclear explosions are there? Not many. Okay, but there are a lot of quarry blasts. Apparently America loves to do quarry blasts that gets recorded. I don't know. Anyway, HoloViews has a very nice relationship to Datashader. Datashader does not depend on HoloViews, but HoloViews has a very rich support for Datashader, so that pretty much anything you can display in HoloViews is not too hard to make it also be data shaded, so you can just handle any sort of data. The quarry blast, that amount of data would be no problem. The number of earthquakes is a problem. That's millions of data points. So, okay, so you can dive into that if you want. You don't need it if you're going to use small data sets in your next example here. So to get to that, so my daughter is actually doing the teen track, and it looks like she just finished, so I better answer her. What room is this?
106.
Can you come to room 106, please? Yep. All right, see you. So you'll meet my daughter? Because this runs till 5:30. All right, so the advanced dashboards is basically going to be, it's about taking the advanced plots that are all connected up and the dashboards and making that be one thing, which is a dashboard where all the plots are connected up and you can do anything you want with anything. That's what the whole tutorial is leading up to. All of the individual pieces are valuable on their own, but together they allow you to do full-fledged delivery of cold data-driven apps. So we start out the same, and then we basically set up very similar things as before, and get a plot of the overlaid raster and the point data. And this is essentially what we had in the output of the previous one, before the one from tutorial 6. That's the output of that. And then we want to start adding widgets, essentially. Before that, you should probably learn about .apply. I don't see where that shows up here, though. Here we go. This is a syntax for Mo. Okay. So essentially at this point we have plots generated roughly as we had before. And we need to be able to update the contents of each of these things according to some widgets. And so we'll see how to do that here. let's make some widgets. So now we're connecting widgets to plots, which we haven't done before. So this is probably as good a place as any to illustrate .apply. So here we created a float slider. The float slider is degree distance. Like, remember what I said about the streams can be anything? In this case, a stream could be a panel widget. A stream is something that has parameters, and those parameters are set from something. That's a widget, right? A widget is something that has parameters, and somehow those values are set. So we can use a widget as a stream, and that's what's happening here. We set up a widget. It's saying essentially how far around a point are we going to include into these summary diagrams. When we do a histogram, what's the spatial radius in degrees that we're going to include in that histogram? So far so good. And then how does it connect up? So let's look here. We're displaying a panel column. So we need panel because we're displaying panel widgets here. We've got a panel column. It consists of one thing on the top, which is a slider, followed by a row of two things. What are these two things? Well, the one of them is the histogram, one of them's a scatter. And how does that work? The first one is the histogram. We're taking a filtered data set. We're applying this function to that data set. And then that particular function, I think Tom may have mentioned this earlier. This is here we've set this function actually very conveniently to the degrees has now been set to the value of that widget. So this is something very handy that HoloViews objects support. You can set if you have you can use the apply function, and it'll take the dynamic value of whatever this slider is and apply it to the degrees dist argument of this function. Does that make sense? So there's a function here, earthquakes around point. That must be up here somewhere. There we go. It's got an argument, degrees dist. That's the distance in degrees. And what we're doing here is we're saying, when you call this callback, you can pass in this value of this widget. Okay? And then the same, but this other argument is not going to be from a widget. It's going to be called from the index of the tap stream. So this is a callback. It takes various things, but some of those are driven by tapping, and some of them are driven by a slider, but it doesn't know or care. That make sense? Okay, so that's how we're setting things up here to be responsive to this. In this particular case, the index isn't changing because I'm nowhere near the plot. It's up here somewhere. If I were to change that, it would affect these immediately, and presumably also these down here. I didn't notice if it changed. Yeah. So you see that the selecting on the plot affected the index, but the degrees is affected by this widget. And it's all just because we set it up that way. We said the degrees of this callback are going to be set by this parameter value, and the index of this callback is going to be set by the selection above. Both of them are objects with parameters. Both of them parameters have names, and it's going to map that name into that. In this case, it's the same name. Here, it's a different name. But either way, it's going to pass that into the argument needed by earthquakes around point, and earthquakes around point is going to is what we're going to. So basically, we're taking the filter data set and applying the histogram, which is up somewhere else. Where's histogram? There it is. Okay, so there's a histogram function and a scatter function. Those are why we get two different things here. And we are taking this filter data set and applying it once to get a histogram, once to get a scatter object. But in either case, they happen to take the same inputs. They just give different results. Okay, and then the last bit, we're going to add another widget for the color map. And again, we're going to connect that up to a HoloViews object. In this case, it's the rasterized population. We're going to say apply to the option, the color map option, the value of this widget value. So again, it's a reactive thing. Color map could have been blue, It's not blue, it's whatever the value dynamically is of this widget right here. So if you have an option, you can either set that option to a value or you can set it to a widget. Well, the value of a widget. And if you set it to the value of a widget using the syntax where you select the underlying parameter, then it'll dynamically and reactively respond to that widget. So if you look at all, and so pull that all together, then you'll end up with this, which I should probably just do show so you can see it. Then you'll build up this particular dashboard, which is not using the defaults it had, so it kind of looks funny, but whatever. This is probably a better default. So it's got this, which is what we saw was connecting up as a plot where we're driving the thing that we're the selection over here determines the data that we're seeing. It's filtering the data set by that location, making this plot, and then making this plot. And all of those depend and respond to these two depend and respond on the degree distance. And this plot depends and responds to the color map, because that's how we connected it up. Okay, so now we're done. We have a data set, we have a shareable dashboard. We present that to our boss, we get a promotion, and we succeed in life. Okay, so now you go off and for 20 minutes you get to do the same thing with at any level of ambition that you have. So take a step back, think about it. Okay, what do you want to attempt? And we will wander around and try to give you advice, but we can't, obviously there are a lot of you, so we can't help you. We can help you with the isolated simple questions. Basically try to set an ambition. What sort of thing would you like to create? If you want it to be something with arbitrary plotting in some arbitrary library that you're good at and you're comfortable with that, great, go for it. Otherwise, follow more closely to our examples, see how you can do that. If you want to add interactivity, connecting things up, great, start with something we showed you and try to work from that. If you want to be, say, I just want to do something that will succeed, then make a dashboard with an image and a data frame and maybe one plot. And then maybe work up to adding a widget to control maybe the row in the data frame or the column in the data frame, let's just say. So do something appropriate for where you feel like you are in this tutorial and try it out. And whatever you do, you're probably going to hit some problem. Then call us over. Okay, good luck. All right, officially this is over. Unofficially we'll be around all conference. We'll see you around. Send us open issues if you have a problem. Be in touch.